Welcome, curious minds and sleepy thinkers. You've found a soft place to land where the questions are big and the pace is slow enough not to jolt you out of your pillow cocoon. Tonight, we're going to tiptoe into one of the most mysterious questions ever asked. Did life once stir on distant Mars? A planet now cloaked in crimson silence. We'll drift through the incredible journeys of brave little explorers, tiny metal souls sent across the vastness to listen, to touch, and to wonder. But don't worry, we'll take it slow. This isn't a race through equations or a lecture on mechanics. It's more like floating through a galaxy of ideas with a cup of chamomile tea, letting the gentle hum of discovery lull us into a deeper understanding of our place in the cosmic tapestry. We'll explore how these metallic wanderers with their curious eyes and diligent arms sought to unravel the ancient secrets held within the red planet's dusty embrace. So settle in, breathe deeply, and let your thoughts journey far beyond the Earth to a world bathed in the soft glow of distant starlight. Our story begins not with a roar, but with a whisper, a faint signal sent across millions of miles of empty space. Imagine, if you will, a tiny seed, carefully crafted by human hands, setting forth from the blue marble of Earth, bound for a world cloaked in a perpetual blush of red. This seed was not destined to grow a plant, but to awaken a landscape to listen to the silent stories written in the dust and stone of Mars. For many years specifically, since the 12th of June in the year 2018, communication had been lost with one such brave little explorer, a rover known by the name of Opportunity. Its journey, however, had long surpassed any dream or expectation. This pioneering rover, a marvel of human ingenuity and a testament to unwavering curiosity, had survived an incredible 15 years on Mars's harsh, unforgiving surface. Think of that 15 Earth years, a span of time that saw seasons change countless times here on our homeworld, while Opportunity steadfastly continued its lonely vigil on an alien planet. Its original mission, a mere whisper, in comparison to its ultimate endurance, was meant to last for only 90 Martian days, or sols. Yet it persevered, extending its stay not by weeks or months, but by more than 50 times its intended lifespan. It was as if the little rover itself, perched on that distant crimson shore, had simply refused to yield, driven by an unseen thirst for knowledge, a silent yearning to uncover just one more secret. The final chapter for Opportunity unfolded with a profound and poetic simplicity, a reflection of the very forces it had come to understand. A global dust storm, a swirling vast expanse of fine Martian particles, rose like a curtain across the sun-drenched sky. For several months, this relentless veil blocked the life-giving sunlight from hitting its solar panels, the very wings that had allowed it to soar through the Martian days. Without the sun's gentle kiss, its batteries, once brimming with energy, slowly, inexorably, began to wane. It was not a sudden violent end, but a quiet fading, like a distant lantern slowly dimming as its oil runs out, leaving only the memory of its light. This video, our journey tonight, is a gentle recap of Opportunity's entire mission. From its very first landing, a delicate touch on an unknown world, to that final encompassing dust storm. We will retrace its steps, marvel at all the challenges it overcame, each one a testament to its resilience, and celebrate the profound discoveries it made along the way. By the end of this quiet exploration, I think you'll agree with me that it was indeed a truly remarkable mission. A voyage that contributed a huge, almost immeasurable amount to our knowledge of the red planet, transforming our understanding from vague guesses to concrete insights. And it is this very knowledge, gathered by Opportunity and its silent brethren, that has paved the way for the missions we are seeing today. Like Perseverance, a new generation of explorers, standing on the shoulders of giants, pushing the boundaries of what is possible, delving even deeper into the Martian mystery. Opportunity, with its unwavering gaze, answered questions that had long haunted humanity. It sought to know, did Mars once have a more substantial atmosphere, a thicker blanket of air that could hold warmth and nurture life. Did it harbor huge bodies of liquid water on its surface, vast oceans or flowing rivers as we do here on Earth? And was it once more like Earth, a vibrant blue-green world? And if so, what profound cataclysmic changes transpired to transform it into the barren red expanse we observe today? I am Alex Molan, and you are watching Astrum, and together we will gently follow the record-breaking journey Opportunity took on Mars. Let's start right at the very beginning, at that first tentative touch on a foreign world. A moment of extraordinary courage and hope, not just for a machine, but for all of humanity's boundless curiosity. Having launched on a Delta II heavy spacecraft, a titan of engineering pushing our dreams towards the stars, Opportunity embarked on its solitary voyage. It landed on the other side of Mars from its sister rover Spirit about 3 weeks after Spirit had already touched down. Imagine them two tiny metallic twins, separated by the vast, silent curve of a planet, each beginning its own unique chapter in the grand Martian saga. Their journeys were intertwined, yet distinct, a testament to the myriad ways in which a world can hold its secrets. Opportunity's descent was a carefully orchestrated dance between gravity and technology. It used a parachute to slow itself on its initial plummet through the thin Martian atmosphere, a delicate silk flower unfurling against the crimson sky. Then, just before its final embrace with the surface, it fired some rockets, a brief controlled burst of power to cushion its landing. The effects of this fiery kiss are still evident even today, captured in the images sent back to Earth. You can see it in this lighter patch of ground, a gentle scar left on the Martian landscape as seen by the Mars Global Surveyor, a watchful eye from orbit. It's a subtle reminder of the precise, powerful forces at play in this ballet of arrival. As it touched down, Opportunity didn't simply land. It first bounced a series of soft, giant leaps cushioned by its protective airbags, like a cosmic ball landing softly on an uneven field. And then, as if guided by an unseen hand, it came to rest inside a tiny 22-meter crater, a perfect unassuming bowl in the Martian terrain, now affectionately known as Eagle Crater. The heat shield and parachute, like discarded remnants of a chrysalis, ended up a few hundred meters away, silent witnesses to the successful birth of this new explorer. The scientists at NASA, watching from millions of miles away, were so excited by this almost unbelievably precise landing that they called it a hole-in-one. Imagine the quiet elation, the silent cheers that rippled through the control room, a moment of profound relief and triumph. Although in truth, they weren't actually aiming for this specific crater. They didn't even know it existed until their eyes through Opportunity's first images got there. It was a beautiful twist of fate, a serendipitous gift from the Martian landscape, as Opportunity actually landed about 25 kilometers away from its intended target. Sometimes the universe, in its boundless wisdom, guides us to discoveries we never anticipated, placing us exactly where we need to be, even if we didn't know the address. As Opportunity emerged from its protective shell like a butterfly from its cocoon, the first thing it did was have a look around. Its panoramic eye, the panoramic camera or PANCOM, began to slowly, deliberately survey the surrounding area, taking in its new home. It saw some outcrops, only a few centimeters tall, delicate rock formations that seemed to rise gently from the dusty ground. These miniature cliffs were made up of extremely fine dust, each grain far smaller than the grains typically found in Earth's sandstone. It was a subtle but profound difference, hinting at a Martian geology shaped by forces distinct from our own. Both Opportunity and its sister Spirit were primarily on Mars for a grand overarching quest, its geology. Their ultimate goal, the silent beacon guiding their every move, was to see if Mars was ever a place that was conducive to life. Not just teeming with it, but simply having the right conditions, the gentle warmth, the essential liquids for life to possibly, perhaps have taken root. The way they approached this profound question was by looking at rocks for evidence of water. These ancient stones, like silent historians, contain clues about their past, their formation, and the environments they witnessed millions of years ago. By deciphering these stony narratives, scientists hoped to gain an idea of what Mars might have been like in its distant, mysterious youth. Opportunity, with its methodical curiosity, began to explore the outcrop closely over the course of the next few weeks. It was a slow, deliberate dance of observation and analysis, and already in those early days, it began discovering evidence that, in the past, some kind of moving current had made the bedrock dip. Imagine ancient unseen forces, perhaps a slow, relentless flow, subtly sculpting the very foundations of the planet. However, at this early stage, it wasn't clear if it was water that had done this, a gentle stream, or a powerful flood, or perhaps a volcanic flow, molten rock cooling into strange patterns, or even the persistent whisper of wind shaping the land over eons. You can see this intriguing pattern in the images it sent back to us, where the thin rock layers are not parallel to each other, but subtly inclined, a silent testament to a dynamic past. On Sol 30, Opportunity's 30th Martian day, on its surface, it got close to the outcrop, its robotic arm extending with a purposeful grace. It then used its rock abrasion tool, affectionately known as the rat, to drill into a section of the rock face. This wasn't a violent act, but a delicate scraping, a way to peel back the outermost weathered layer, revealing the pristine, hidden truth beneath. As it did so, it found something known to geologists as vugs or voids in the rock. Imagine tiny pockets, empty spaces, the result of crystals having been eroded away, leaving behind ghostly impressions of their former selves. It was as if Opportunity had stumbled upon the remnants of ancient miniature cities, long abandoned, their inhabitants vanished into the sands of time. But the rock held more secrets. It also contained hydroxide ions, microscopic signatures that hinted at a profound truth. This meant that water was likely present when the rock formed. Imagine water not just as a fleeting presence, but as an integral part of the rock's very being, woven into its crystalline structure, a silent, enduring memory of a wetter past. It was a gentle whisper, a first undeniable clue in the grand puzzle of Martian water. Next up for Opportunity was a task that felt profoundly Earth-like, yet unfolded on an alien world. It was to dig a trench in the soil for further analysis. It achieved this by digging its front wheels into the soil, while the back four wheels held it firmly in place, a surprisingly graceful, almost balletic maneuver for a machine. After some shuffling about, a careful, methodical dance that lasted for 22 minutes, it had made a trench 50 centimeters long and 10 centimeters deep. It was a small window into the Martian subsurface, a glimpse beneath the veil of the familiar red dust. And what wonders did this trench reveal? Under the top layer of soil were some things it had not seen before, a collection of intriguing novelties. These included shiny little pebbles and grains so small, this microscopic image can't even distinguish between them. Imagine pebbles glistening like tiny jewels, perhaps fragments of ancient forgotten minerals, and grains so infinitesimally small that they blurred into a single continuous whisper of dust. It was a tantalizing glimpse into the subtle variations of Martian soil, a reminder that even in seemingly uniform landscapes, diversity and wonder abound. Each tiny grain held a story, a fragment of Mars's deep past, waiting to be deciphered. Over the course of the next few Martian weeks, having discovered everything it needed to within the confines of Eagle Crater, Opportunity prepared to embark on a new chapter. It powered out of the crater with a steady, determined pace at an average speed of 1 centimeter per second. Imagine a tiny explorer leaving its first comfortable home, venturing forth with quiet courage into the unknown expanse. Its next destination, a beckoning horizon on the flat Martian plains, was towards the next biggest crater in the vicinity, Endurance Crater, a grander, more imposing geological feature about 200 meters wide. It was a natural progression, a step towards a more extensive and perhaps more revealing exploration. On its way, it passed by a tiny little crater, a brief, almost ephemeral landmark called Fram. It took a photo, a fleeting acknowledgement of this small circular depression, but didn't stop for long. Its destination Endurance held a greater promise, a more profound scientific allure that drew it forward with an almost magnetic pull, and so our gentle rover Opportunity, with the quiet persistence that would define its extraordinary mission, moved ever onward, leaving the intimate embrace of Eagle Crater behind and turning its tireless gaze towards the grander, more mysterious depths of Endurance. Each slow turn of its wheels, each faint signal sent across the cosmic void, was a testament to the enduring human spirit of exploration, a silent echo of our relentless quest to understand the universe, one gentle step at a time. The red dust swirled softly in its wake, a temporary memory of its passage across the timeless crimson shore. Let us now gently drift into the intricate details of Opportunity's work, that quiet, diligent probing of the Martian surface, seeking the subtle fingerprints of a bygone era. For it was not enough for our little rover to simply land. Its true purpose was to listen, to decipher the ancient script written in the very bedrock beneath its wheels. As Opportunity emerged from the initial excitement of its landing in Eagle Crater, its mission truly began to unfold, a slow, methodical dance of exploration that often felt more like a meditative study than a frantic dash for data. Think of Opportunity's sophisticated instruments as a set of highly sensitive, almost poetic senses. Its PanCam, the panoramic camera, wasn't just taking snapshots, it was painting a vast canvas of its new world, capturing the textures, the colors, the gentle undulations of the Martian terrain. It was through this lens that the early mysteries began to reveal themselves. The sight of those low-lying outcrops, just centimeters tall, composed of incredibly fine dust, stirred a quiet wonder. Imagine dust so infinitesimally small that each particle was far tinier than a grain of sand on our Earth. What forces, what ancient winds or waters could have refined this material to such a delicate consistency? It was like finding a tapestry woven from the finest, most ethereal threads, hinting at a craftsmanship beyond our immediate comprehension. The primary objective, the beating heart of Opportunity's scientific quest, was the search for evidence of water. This wasn't a casual inquiry. It was the very key to understanding Mars's past habitability. For where there is water, there is the possibility of life, even if only in its simplest, most microbial forms. Rocks, in their quiet stoicism, hold the profound secrets of their birth and evolution. They are like old weathered books, each layer a page, each mineral a word, waiting for a patient reader to unravel their narratives. Opportunity, with its diligent tools, was poised to be that reader. Over the course of the next few weeks following its gentle landing, Opportunity began its meticulous study of that first outcrop. It was a period of intense, focused observation, each movement of its robotic arm deliberate, each image carefully captured. And during this patient scrutiny, a remarkable discovery began to emerge, a subtle hint of ancient dynamics. Opportunity found evidence that in the past, some kind of moving current had made the bedrock dip. Picture, if you will, the layers of rock like delicate sheets of parchment, subtly angled, not perfectly parallel, as if laid down in still waters, but tilted as if sculpted by an unseen force. This geological feature, known as crossbedding, whispered tales of ancient currents, of something flowing across the landscape, depositing sediments in a particular directional pattern. Yet, in those early moments, the mystery was still profound. The rover's instruments could detect the tilting, the directionality, but the precise nature of the sculptor remained elusive. Was it water that had flowed, perhaps a slow ancient river, or a gentle tide washing over a shallow basin? Or could it have been a volcanic flow, a molten river of rock cooling and solidifying in a way that mimicked the flow of liquid? Or perhaps the most persistent force on Mars, the wind tirelessly shaping the landscape over eons, had created these subtle dips? The answer at that moment was a beautiful ambiguity, an open question inviting deeper exploration. To truly understand this enigma, Opportunity needed to get closer to feel the texture of the rock, to probe beyond its weathered skin. And so, on Sol 30, its 30th Martian day, our little explorer moved with purpose towards the outcrop. Its robotic arm, like a sensitive limb, extended, culminating in the deployment of its rock abrasion tool rat. This wasn't a destructive act, but a gentle, controlled scraping, a peeling back of the outermost layer of rock, which on Mars is often covered in a fine oxidizing dust, a patina of eons. The rat whirred softly, grinding a small circle, revealing the pristine, unblemished rock beneath a fresh canvas for scientific inquiry. And as the rat performed its delicate work, the rock revealed its deeper secrets. Within the newly exposed surface, Opportunity found something intriguing to geologists: vugs or voids in the rock. Imagine tiny hollow spaces like miniature ghost rooms nestled within the solid stone. These were not mere random imperfections. They were the echoes of a past presence, the result of crystals having been eroded away. Picture this: millions of years ago, certain minerals, perhaps salts, formed within the rock. Then, at some point, a fluid, quite possibly water, flowed through, dissolving these crystals, leaving behind their distinct hollow imprints. It was a silent, powerful testament to a transformative process, a beautiful example of nature's subtle artistry. But the rock offered an even more profound clue. Through its sophisticated instruments, Opportunity also detected the presence of hydroxide ions. This was a truly significant whisper, for hydroxide ions are chemical signatures strongly associated with the presence of water in the formation process of minerals. Imagine water not just flowing over the rock, but being an integral part of its very birth, woven into its molecular fabric. It was a quiet confirmation, a scientific yes, suggesting that when this particular rock took shape, liquid water was likely a key ingredient in its genesis. This was a critical piece of the puzzle, moving beyond mere inference to a more direct chemical indication of water's ancient presence. The story of the Martian surface is not just written in rock, but also in the very soil beneath. And so the next step for Opportunity was to perform an act that felt both familiar and utterly alien: dig a trench in the soil for further analysis. This wasn't a grand sweeping excavation, but a meticulous, controlled maneuver. Opportunity positioned its front wheels and, with surprising dexterity for a 6-wheeled robot, dug them into the loose Martian soil, while its 4 back wheels held it steady, acting as anchors. It was a slow, deliberate process, a quiet shuffle that lasted for 22 minutes, a patient effort to create a window into the subsurface, and the result of this patient labor was a trench 50 centimeters long and 10 centimeters deep. Imagine a perfect miniature ditch carved by a robotic hand on an alien world. What lay beneath the surface, hidden from the omnipresent red dust? The revelations were subtle, yet profound. Under the top layer of soil, Opportunity found some things it had not seen before: a collection of intriguing new textures and compositions. Among these were shiny little pebbles, small glistening fragments that seemed to sparkle faintly in the Martian light, perhaps hinting at a different mineral composition or a unique weathering process. And then there were grains so small, this microscopic image can't even distinguish between them, a testament to the incredibly fine, almost ethereal nature of some Martian soil particles. This discovery, though seemingly minor, painted a richer picture of the Martian surface's complexity. It suggested that even within a seemingly uniform landscape, there were subtle variations, layers of history, waiting to be unearthed. The shiny pebbles, perhaps remnants of ancient impacts or volcanic activity, and the impossibly fine grains, perhaps the product of eons of aeolian wind-driven erosion, spoke volumes. It was as if Opportunity was peeling back the pages of an ancient book, each new layer of soil revealing a different chapter, a different story of Mars's long and dynamic past. The trench was a small window, but through it, scientists on Earth gained a more intimate understanding of the subtle wonders hidden just beneath the crimson veil. having patiently, diligently, and thoroughly explored everything it needed to within the confined yet scientifically rich embrace of Eagle Crater opportunity, was ready for a new horizon. The early weeks had been a period of meticulous initiation, a quiet gathering of initial truths. But the grand narrative of Mars was vast, stretching far beyond this gentle bowl in the landscape. And so, over the course of the next few Martian weeks, our little rover, imbued with a quiet determination, prepared to embark on its next great journey. It powered out of the crater with a steady, almost serene resolve, its wheels slowly, rhythmically turning. Its average speed was a mere 1 centimeter per second, a pace that by human standards might seem impossibly slow. Yet on Mars, where patience is a virtue and the landscape spans eons, this was a testament to its methodical efficiency. Imagine a tiny 6-wheeled pilgrim slowly, deliberately making its way across a silent, crimson desert, each turn of its wheel a step further into the unknown. Its new destination, a beckoning promise on the distant horizon, was Endurance Crater. This was a significantly larger geological feature in the vicinity, a more imposing circular depression approximately 200 meters wide. If Eagle Crater was a gentle introduction, Endurance was poised to be a deeper, more challenging chapter, a grander stage for opportunity's unfolding discoveries. The path between these two ancient scars on Mars was a flat expanse, seemingly featureless, yet holding its own subtle complexities. On its way, opportunity made a brief, almost wistful pause, a momentary acknowledgement of a smaller landmark. It passed by this tiny little crater called Fram. It was a fleeting encounter. Our rover took a photo, a quick visual note of its existence, a simple acknowledgement of its presence in the vast Martian canvas. But it didn't stop for long. The call of Endurance, with its promise of deeper layers of history, was too strong, too compelling to linger in the shallows. Fram was a silent, unassuming punctuation mark in Opportunity's long journey, a brief moment of visual interest before the main act. And so, with its unerring sense of purpose, our gentle explorer continued its deliberate march on Sol 84. Opportunity finally reached the edge of its anticipated destination, Endurance Crater, and paused metaphorically to have a look inside. Imagine standing at the rim of a colossal ancient bowl, its sides sloping down into a vast, silent amphitheater of time. Mission planners, those diligent orchestrators of this cosmic ballet back on Earth, already knew that Endurance held a tantalizing secret, many layers of rock to be investigated. These layers, exposed like the pages of a deeply buried book, promised to reveal an even older history of Mars, perhaps stretching back to the very dawn of its existence. They wanted to have a closer, more intimate look at them, to read the stories etched in their strata. The challenge, however, was not simply getting in. Opportunity, with its robust design, could certainly descend into the crater. But the crucial question, the silent anxiety that hung in the air of the control room, was whether it could get out. The slopes could be steep, the terrain uncertain, and once inside, any misstep could mean permanent entrapment, the quiet, poignant end of a mission. And so, Opportunity, with its methodical caution, circled around the crater, its cameras patiently mapping the terrain, looking for a good entry point. It was a dance of careful assessment, weighing the scientific promise against the inherent risks, seeking the most gentle yet effective path into the heart of this ancient mystery. The red dust, undisturbed for millennia, awaited its gentle metallic touch. The silent conversation between Opportunity and its human guides continued across the vast, echoing expanse of space. As our little rover patiently circled Endurance Crater, its sensitive eyes, the PanCam meticulously mapped the terrain, painting a detailed picture of the ancient slopes. The mission planners back on Earth, those distant orchestrators of this grand cosmic ballet, were faced with a profound decision. The scientific allure of Endurance was undeniable. Its sheer size, the promise of deeper, older rock layers, whispered tales of a Mars even more ancient than the one revealed in Eagle Crater. It was a tantalizing glimpse into a hidden past, a geological treasure trove waiting to be unlocked. But the challenge was significant. While getting into endurance might not be a problem, the critical question, the quiet worry that rippled through the control rooms, was always about getting out. The Martian landscape, beautiful yet unforgiving, held its own subtle traps. A slope too steep, a patch of sand too soft, and our intrepid explorer could become permanently mired, a silent sentinel forever gazing into the crater's depths. This was the delicate balance they continually weighed, the immense value of the science versus the inherent risks of an alien terrain. Each pixel of data, each minute detail from Opportunity's camera fed into this complex equation, a profound exercise in remote decision-making. And so the weeks turned into Martian days, and the days into Sols. By Sol 127, after much deliberation, much careful analysis of the images and topographical data, the mission planners made a courageous, almost audacious choice. They decided to drive Opportunity into the crater, even if the risk of it being unable to get out was palpable. The value of the science that could be garnered, the potential for groundbreaking discoveries hidden within Endurance's ancient embrace, was simply too promising to pass up. It was a leap of faith, a testament to their unwavering belief that the secrets of Mars were worth the gamble, that the pursuit of knowledge justified the inherent danger. So, with a quiet solemnity on Sol 131, our little rover began its delicate descent. It carefully edged its way over the ridge of the crater, its wheels gripping the Martian soil with a determined precision. Imagine the tension in the control room, millions of miles away, as they watched the telemetry, each data point a breath held in suspense. As a precautionary measure, once it had just tipped over the edge, Opportunity tried to reverse back to see if it could. It was a test of the threshold, a final check before committing fully to the descent, and much to the quiet relief of the team, it could. Luckily, the angle of the rim was only 18 degrees, well within Opportunity's known safety margin. It was a small victory, a subtle reassurance that the path chosen, though challenging, was navigable. And with that confirmation, the grand excursion into the crater began in earnest, a journey into the ancient heart of Mars. Once inside, the vast, silent amphitheater of Endurance Crater, Opportunity settled in for an extended stay. It spent an astonishing 180 sols within its confines, a period of deep, intimate exploration. Imagine a tiny archaeologist meticulously sifting through the layers of time, each movement slow, deliberate, and purposeful. Its journey within the crater was a spiraling descent into geological history, each turn revealing a new facet of Mars's ancient past. One of the key areas it explored was a region named Karatape. Here, Opportunity carefully observed various layers in the bedrock, like the stacked pages of an immense weathered book. These layers, each with its own subtle nuances in color and texture, whispered tales of different eras, different environmental conditions that once prevailed within the crater. They were not just rocks. They were geological timelines holding clues to the forces that shaped them over eons. As it traversed the crater floor, Opportunity was always mindful of the inherent dangers. It went near to, but not into, some sand dunes. These seemingly innocuous ripples of Martian sand held a treacherous secret, the risk of getting stuck. Mission planners, ever cautious, had learned from both theoretical models and the very real dangers posed by such loose, shifting terrains. The thought of the rover becoming permanently mired, its journey abruptly ending in a silent sea of sand, was a constant, sober warning. So Opportunity navigated with a delicate grace, observing the dunes, appreciating their beauty, but maintaining a respectful distance, like a sailor avoiding hidden shoals. Amidst its geological explorations, Opportunity also offered us glimpses of the Martian sky, a canvas often dominated by dust, but sometimes revealing more ethereal beauty. It saw some wispy clouds, delicate formations similar to Earth's cirrus clouds. Imagine these delicate streaks, high in the thin Martian atmosphere, catching the faint sunlight, a subtle reminder that even on this desolate world, atmospheric dance still occurred. It was a poetic touch, a brief visual connection between our blue planet and the crimson one, a shared beauty across millions of miles. And lastly, in its deep dive into endurance opportunity, made its way to a truly impressive geological feature, a cliff face called Burns Cliff. Imagine a grand, majestic wall of rock rising from the crater floor, its face etched with the passages of time. It was an impressive-looking cliff face with various layers separated by broken-up rocks and dust. This wasn't just a static formation. It was a dynamic tableau showcasing the intricate processes of erosion deposition and possibly ancient water activity. Each separated layer, each piece of broken rock, was a fragment of a larger story, a testament to the powerful shaping forces that had sculpted Mars over billions of years. Burns Cliff stood as a silent, majestic monument to endurance's ancient complex history, waiting for opportunity's patient gaze to unravel its narratives. After its extensive and fruitful exploration within Endurance Crater, a period spanning 180 sols opportunity finally prepared to depart. Its exit, like its entry, was a carefully orchestrated maneuver, a testament to the remote expertise of its human handlers. On Sol 35, it finally left Endurance, its wheels slowly, meticulously climbing the same gentle incline it had descended months before. It was like closing a profound chapter in a captivating book, but the story of Mars was far from over. The time spent within Endurance had been incredibly rich, yielding a treasure trove of scientific data. The information collected by Opportunity meant that scientists were able to confirm that water didn't just cover this area once, but it was in fact episodic in nature. Imagine Mars not as a perpetually wet world, but one that experienced periods of profound change, cycles of wetness and dryness. This implied a dynamic past, a climate that fluctuated, perhaps influenced by subtle shifts in the planet's orbit or axial tilt. Think of it like this: not a single grand continuous ocean, but rather a series of floods that would have washed across the landscape before drying up again. Picture ancient deluges, perhaps triggered by melting ice, or intense rainfall from a denser atmosphere spreading across the vast plains within the crater. And then, as mysteriously as they arrived, these temporary bodies of water would recede, leaving behind their telltale deposits in the rock layers. It was a powerful revelation, painting a picture of a Mars that was once dynamic, perhaps even tumultuous in its hydrological cycles. At any rate, the data from Endurance also suggested that the water here would have never been that deep. This wasn't a vast abyssal ocean, but rather a shallower, more transient presence, perhaps a series of interconnected ponds, ephemeral lakes, or widespread sheet flows. It helped refine our understanding of Martian water, moving from broad speculation to more nuanced, detailed interpretations, grounded in direct observation from the surface. This substantial discovery from within Endurance Crater was a cornerstone in building our understanding of Mars's wetter past, laying the groundwork for even deeper questions and explorations. After that profound and substantial discovery within the ancient confines of Endurance Crater Opportunity, our diligent explorer set its sights on a new, unexpected target. Its next stop on its grand adventure was to investigate its own heat shield. This wasn't a scientific goal in the traditional sense, but rather a return to its own origin story, a visit to a piece of its journey that had detached and fallen away during the dramatic descent to the Martian surface. It was a unique opportunity to examine an object of earthly origin precisely where it had landed on an alien world, and remarkably on the way it came across a rock that was later confirmed to be a meteorite named Heat Shield Rock. Imagine the serendipity, the pure chance of this encounter. Our rover, making its way across the Martian plains, stumbled upon a piece of cosmic history, a visitor from the vastness of space. This wasn't just any rock. It was a first meteorite to be identified on another planet. Think of the significance of that moment, a piece of the universe untouched by earthly hands, now being examined up close by an emissary from Earth itself. It was a profound intersection of cosmic journeys, a quiet, astonishing discovery that added another layer of wonder to Opportunity's already remarkable mission. Heat Shield Rock, a silent traveler through the void, now revealed its secrets under the gentle metallic gaze of a fellow voyager. With this unexpected yet delightful detour, Complete Opportunity then set a course for Erebus Crater. This was another major landmark, a new destination beckoning on the horizon, promising further geological insights. To reach it, the rover had to press ahead through a region aptly called the etched terrain, a landscape likely characterized by subtle sculpted features formed by ancient erosional processes. Its primary goal during this traverse was to search for more bedrock, those solid foundational layers of rock that held the deepest secrets of Mars's past. Bedrock, unlike the shifting sands, offered a stable, readable surface where the planet's geological narrative was most clearly etched. However, the Martian landscape, even on seemingly flat plains, holds its own quiet dangers. While traversing this area on Sol 445, a day that would become etched in the memory of the mission team, Opportunity got stuck in a 30-centimeter sand dune. Imagine a tiny car, its wheels spinning futilely, sinking deeper and deeper into loose, fine sand. Things did not look good for the rover. This wasn't a minor bump. It was a significant entanglement. All 4 of its corner wheels were dug into the dune by more than a wheel radius, meaning they were deeply embedded, struggling against the relentless pull of the granular trap. This particular dune, with its unexpected tenacity, came to be known rather poignantly as Purgatory Dune. The scene was one of profound stillness, yet intense, remote activity. Opportunity stayed motionless for just short of 20 Martian days. Imagine the quiet anxiety back on Earth, the frantic energy of the mission planners. They were faced with a daunting challenge: how to extricate their invaluable explorer from this silent, sandy embrace. This wasn't a problem that could be solved with a quick tug or a simple push. It required immense patience, meticulous planning, and a deep understanding of the rover's capabilities and limitations. To find a solution, the team embarked on a process that was both intensely scientific and deeply creative. They simulated the scenario on Earth, meticulously recreating the conditions of Purgatory Dune in their test labs. Imagine building a miniature Martian landscape, carefully calibrated to mimic the treacherous sand, and then experimenting with a replica of Opportunity. They tried various methods, exploring every possible angle, every subtle maneuver, every tiny shift in wheel motion. It was a period of trial and error, of hypotheses and tests, all conducted millions of miles away, yet with an urgent, palpable sense of real-time consequence. Only after these exhaustive simulations and painstaking tests did they order Opportunity to try anything. It was a moment of profound trust, a silent command whispered across the void. On Sol 461, the rover began its delicate, painstaking maneuvers. It advanced a few centimeters, a tiny, almost imperceptible shift, just to see if it was doing what their tests had predicted. Each small movement was a gamble, each millimeter of progress a victory. And so, the quiet drama of Purgatory Dune unfolded over the course of the next 20 Martian days. Opportunity moved with an almost unimaginable slowness, a few centimeters at a time. After each agonizingly small advance, it would take a photo of the progress and send the results back to mission control. Imagine the anticipation as those images slowly downloaded, revealing the minute shifts in the rover's position, confirming whether their remote instructions were indeed working. It was a triumph of patience, a testament to the methodical, determined spirit of both the machine and its human partners. By Sol 483, after those agonizing weeks of slow, deliberate movements, Opportunity, with a quiet triumph, had successfully escaped the dune. All 6 of its wheels were on firmer ground, no longer sinking into the treacherous sands of Purgatory. Imagine the collective sigh of relief, the wave of quiet celebration that would have swept through the control room back on Earth. It would have been truly disappointing, a poignant and premature end, if this intrepid explorer had traveled for a year on Mars just to get stuck by a 30-centimeter dune. The resilience of the rover and the unwavering dedication of its human team had overcome this significant obstacle. But the ordeal of Purgatory Dune was not just a challenge to be overcome, it was also a profound learning experience. Opportunity, with its scientific curiosity intact, studied Purgatory Dune for another 12 Martian days before setting off again on its way to Erebus Crater. It was as if the rover, having intimately experienced the dune's treacherous nature, now sought to understand its very essence, to extract every possible piece of knowledge from its challenging encounter. This prolonged study allowed scientists to gather valuable data on the properties of such fine loose sands insights that would be crucial for future Martian exploration, and the lessons learned from Purgatory Dune had a tangible, enduring impact on Opportunity's future journeys. During its subsequent journey, mission controllers uploaded updated software to Opportunity to prevent it from getting stuck again. This wasn't just a simple patch. It was a profound act of learning, a direct application of the hard-won wisdom gained from that harrowing experience. The software was designed by learning what happened from the experience at Purgatory, incorporating new algorithms that would detect wheel slip much more effectively and automatically adjust the rover's movements to prevent it from sinking. With this new improved software update, Opportunity was now ready to carry on its adventure at Erebus Crater, not just a survivor, but a stronger, wiser explorer. Better equipped to face the subtle dangers of the Martian landscape, the gentle hum of its systems, now enhanced by the lessons of the past, carried it onward towards new mysteries. As Opportunity, now a more seasoned traveler, approached Erebus Crater, a new chapter in its enduring journey began to unfold. The landscape itself shifted, revealing long-hidden truths. Our little rover came to sections of ground where the bedrock was exposed, vast ancient expanses of solid rock, no longer hidden beneath a shifting veil of dust. Mission controllers, with a touch of poetic whimsy, named this particular section the Erebus Highway. Imagine a natural roadway forged by the slow, inexorable hand of time, inviting Opportunity to traverse its unyielding surface. As we know, Opportunity's main mission, the very purpose for its journey across millions of miles, was to search for signs of water on Mars, and the most eloquent clues of water's ancient presence can often be found in the planet's rocks. These stoic witnesses hold within their very structure the telltale signatures of past interactions with liquid. To unlock these secrets, Opportunity once again deployed its diligent rock abrasion tool rat, using it to carve circles into the bedrock. This wasn't a destructive act, but a meticulous peeling back of layers, a gentle incision into the planet's skin, revealing the pristine rock beneath. And with its microscopic camera, a tiny, powerful eye on its robotic arm, it meticulously compared the different structures of the rock to search for evidence of water. Imagine the subtle variations. It observed the size and shape of individual grains, the way they were cemented together, the presence of voids or mineral deposits. Each tiny detail was a whisper from the past, a clue in the grand narrative of Mars's hydrological history. These were not mere pictures. They were scientific interrogations, each image a question posed to the ancient stones seeking the quiet echoes of water. You'll notice by here that the Opportunity's tracks are in front of the rover. This might seem like a curious detail, a subtle shift in perspective. And indeed, this is still the front camera viewing the path ahead. But sometimes in a testament to the ingenuity and resourcefulness of its human handlers, mission controllers drove Opportunity backwards to even out the wear and tear on the equipment. Think of it as rotating the tires of a car, a simple yet profoundly effective way to extend the lifespan of this invaluable distant explorer. It's a quiet reminder that even millions of miles away, the principles of careful stewardship apply, ensuring that every precious component of the rover serves its purpose for as long as possible. Erebus itself was a fascinating, though subtly disguised, geological feature. It was described as a very old and eroded crater filled with sand with only a few outcrops showing. Imagine an ancient once grand amphitheater, now largely filled in and smoothed over by the relentless passage of time and the ceaseless work of Martian winds. From the ground perspective, it might be difficult to even discern its true nature. You may not have been able to tell it's a crater from the ground perspective because it's so shallow and eroded. It only truly becomes visible, its full vast circularity revealed from the satellite photos taken from orbit, a testament to the different scales at which we perceive the Martian landscape. This ancient weathered bowl was about twice as big as Endurance Crater at 350 meters in diameter. Yet surprisingly, Opportunity never actually went inside the crater, as there was only more dunes in it. The flat sand-filled basin offered little in the way of exposed bedrock, the prime target for Opportunity's geological quest. Instead, our cautious rover stuck to the rim, avoiding larger dunes as it went. This was a strategic decision prioritizing scientific return and rover safety over the mere act of entering a new, if less fruitful, depression. The lessons of Purgatory Dune, though, difficult lingered. Even while carefully maneuvering around these dunes, the Martian terrain continued to present its subtle challenges. Opportunity, despite its enhanced software, hit some soft sand and its wheels sunk in. Imagine a momentary pause, a subtle lurch as the wheel found less firm purchase. But this time, something truly remarkable occurred. Luckily, the software that was installed only a few weeks previously noticed that the wheels were slipping, and it stopped its drive command. This wasn't human intervention in real time. It was the machine's own nascent intelligence at work, a silent guardian protecting itself from harm. You see, Opportunity is not controlled in real time by a person on Earth with a joystick. The sheer distances involved make such direct control utterly impossible. There is too much latency for this, between 6 minutes to 40 minutes, depending on the proximity of Earth and Mars. Imagine the frustration of trying to drive a remote-controlled car with a delay of many minutes. It would be an exercise in futility. So instead, Opportunity is given drive commands using these same navigational images you see here and comparing it with satellite-based imagery. It's a painstaking process. Mission controllers command Opportunity to drive forward a certain distance. Then it will take a new photo to show its progress, waiting for the human eye to confirm its path before the next set of instructions can be relayed across the cosmic void. The genius of the software that prevented Opportunity from getting stuck lay precisely in this autonomy. It meant that mission controllers could get the rover to reverse out without another several-week delay, as had happened at Purgatory Dune. The machine had learned, had become a little bit wiser, protecting itself from repeating past mistakes. This subtle yet profound leap in autonomous capability was a quiet triumph, freeing up precious time for more scientific exploration. During Opportunity's time near Erebus, it also embarked on a remarkable collaboration, a silent dialogue across the Martian sky. It collaborated with ESA's Mars Express Orbiter. Imagine two very different eyes, one on the surface, one orbiting high above, working in concert. The Mars Express Orbiter images the surface of Mars from orbit to search for different types of materials without actually sampling the surface. It sees the broad strokes, the vast patterns, the subtle chemical signatures from afar. The data it collects, while invaluable, can be hard to interpret in isolation. Opportunity, however, with its direct, tangible presence on the ground, could provide the crucial ground truth. It can physically interact with the surface material, confirming whether what the Mars Express data showed was correct or not. Imagine the orbiter seeing a faint whisper of a particular mineral from high above, and then Opportunity carefully approaching that very spot, touching it, analyzing it with its instruments and confirming its composition. This collaborative dance was essential, helping them to refine their future observations, sharpening the vision of both perspectives, weaving together a more complete tapestry of Martian understanding, while Opportunity was still meticulously making its way around Erebus crater. Meticulously reading the ancient script of its rocks, the Martian atmosphere decided to put on a dramatic show. A big dust storm hit a swirling tempest of fine crimson particles rising from the surface to engulf the sky. For a few days as the storm intensified, Opportunity went dark, its signals falling silent, swallowed by the vast opaque veil. Imagine the quiet anxiety back on Earth, the collective holding of breath as their distant emissary ceased its communications. And in a very interesting way, the event offered a subtle yet profound insight into the storm's impact. You could visibly see the difference the dust storm made to the rover as the camera goes from having a clear image to having some dust particles visible. It was like watching a subtle, insidious shroud slowly descend, gradually obscuring the clear vision. Also, the most immediate and critical impact of such a storm is that dust settles on the solar panels like a blanket slowly dimming a light. This meant that Opportunity can't generate as much electricity, its lifeblood slowly being choked by the accumulating particles. It was a stark reminder of the fragile balance upon which its very existence depended. Very fortunately, though Mars in its unpredictable wisdom has occasional cleaning events, these are moments of unexpected grace when the planet itself seems to intervene to aid its tiny visitors. Wind or even a dust devil, a miniature tornado of Martian air, will pass over the rover, blowing the dust off the solar panels and camera. Imagine these ethereal whirlwinds like benevolent spirits sweeping across the landscape, gently dusting off the precious instruments. Because Mars is so dry, this dust is not at all adhesive. It doesn't stick stubbornly to surfaces. And the dust is so fine, almost as fine as cigarette smoke, that it doesn't take much at all to shift it off. It's a remarkable, almost poetic natural phenomenon that has often extended the lives of these solar-powered explorers. You can actually notice this cleaning happen over time too, a subtle yet powerful testament to these Martian breezes. If you were to speed up the footage, a time lapse of days turning into weeks, you would witness the slow, meticulous work of the wind. Look at this fleck of dirt here, a persistent smudge on the camera lens, and observe how it disappears over time. It's a quiet, almost imperceptible transformation, a gradual clearing of the view. Opportunity, unlike its later successors, doesn't have a means of clearing this dust off by itself. It has always relied on these cleaning events, happening a dependence on the whims of the Martian atmosphere. And thankfully, over the course of its incredible 15-year mission, they did numerous times, acting as vital unsung heroes in its prolonged survival. Sadly, however, amidst its continued resilience and the occasional grace of Martian winds, Opportunity began to encounter the inevitable wear and tear of a prolonged existence in a harsh alien environment. During its time at Erebus, the intrepid rover encountered its first mechanical fault. This was not a sudden catastrophic failure, but a gradual persistent challenge. Its arm was getting stuck all the time. Imagine a limb once agile and responsive, now reluctant to obey resisting movement. As observed through its internal diagnostics, there was a broken wire, a tiny yet critical break in the electrical connection that powered the arm's delicate movements. Although the motor still worked if it was given more power, it was a clear sign of strain, a whisper of impending weakness. After careful deliberation, the engineers back on Earth, those distant physicians of the robot, decided the best course of action. They determined that the most prudent approach would be to only stow the arm away while traveling long distances. For shorter movements, where the risk of full retraction was less critical, it would be kept in a hover stow position. Imagine a replica of Opportunity here on Earth, its arm held in a bent, slightly extended posture, being used to test how it can travel with the arm out in this hover stow position, where the arm is out but it bends back at the elbow towards the rover. This was a workaround, a clever adaptation to a challenging reality. They reasoned that it would be better to have the arm stuck while it was out, rather than to try and stow it away to find it can never be used again. At least in the hover stow position, it would be somewhat functional, still capable of minor adjustments and observations, allowing the mission to continue, albeit with a new subtle limitation. The challenges to Opportunity's mechanical well-being? were not isolated. Over the course of the mission up until this point, another persistent problem had begun to emerge, a subtle battle against the biting Martian cold. It was encountering a problem with a heater for a motor in the arm that wouldn't turn off. Imagine a small stubborn flame perpetually burning, draining precious power. Engineers, with their characteristic ingenuity, managed to find a temporary solution. They managed to get away with switching it off with a T-stat switch, a kind of thermal switch that would cut power to the heater if the motor got too hot. It was a delicate balance, an automatic thermostat for a robotic limb. However, as Martian winter drew near, bringing with it shorter days and lower sun angles, the energy equation shifted dramatically. There would be less sunlight, meaning the solar panels would generate less power. And critically, there wasn't enough power to have the heater on all night without severely depleting the batteries. This posed a significant threat to the motor, as extreme cold could cause irreparable damage. To address this, they implemented a more drastic measure. They fixed this by completely disconnecting the batteries at night. It was a bold move, sacrificing consistent power to protect the vital components. This solution, while protecting the batteries, led to another equally challenging problem. There would now be very, very big swings in temperature between day and night. At the Martian equator, temperatures could range from up to 20 degrees Celsius during the day and 75 degrees Celsius at its coldest at night. Imagine the strain on a delicate motor repeatedly enduring such extreme thermal cycles. This drastic temperature variability, compounded by Mars's thin atmosphere, meant the motor would likely wear out faster. Although Mars does have an atmosphere, it is 100 times thinner than Earth, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. It was a constant battle against the profound thermal challenges of an alien world, and the struggle with this particular motor culminated in a more significant setback. At this point in the mission, this motor stalled altogether. Imagine the quiet alarm, the sudden cessation of function. Engineers, ever persistent, found a temporary fix, a way to coax life back into the dormant component by applying more current through the motor. It was a forceful, yet necessary intervention. However, as a precautionary measure mindful of the motor's increasing unreliability, they stowed the arm outside the rover at night in case the motor permanently stalled. This position, visible to the cameras, would allow them to attempt repairs or further analysis even if full functionality was lost. You'll start to notice this in the camera view from now on, a subtle yet persistent change in Opportunity's outward appearance, a visible mark of its long, challenging, and remarkably enduring journey. Each scar, each workaround was a testament to its incredible longevity and the unwavering dedication of its human caretakers, adapting to every twist and turn of its silent, epic voyage. The journey of Opportunity. Our tireless metallic companion on the Crimson Plains was a testament not only to its robust engineering, but also to the constant, vigilant adaptation required in the face of an alien world. As we have seen, the struggle against the subtle, insidious accumulation of Martian dust was a recurring theme, a silent battle for survival against the very elements of its new home. Imagine the rover's solar panels, its life-giving wings gradually becoming veiled by a fine red powder, diminishing their ability to capture the precious sunlight. This was a slow, almost imperceptible dimming, a gradual fading of strength that could at any moment lead to a profound and permanent slumber. Yet Mars, in its unpredictable wisdom, often offered moments of unexpected grace. Very fortunately, this otherwise barren and arid world has occasional cleaning events. Think of these as nature's gentle touch, a spontaneous act of renewal that often extended the lives of our solar-powered explorers beyond all reasonable expectation. These are moments when the Martian atmosphere, in a subtle dance of currents and pressures, orchestrates a profound cleansing. Wind, or even a dust devil, a miniature whirlwind of Martian air, would pass over the rover, blowing the dust off the solar panels and camera. Imagine these ethereal swirling columns of air like benevolent spirits gracefully sweeping across the landscape, meticulously dusting off the precious instruments. It's a remarkable, almost poetic intervention, a testament to the unexpected kindness of an otherwise harsh environment. The effectiveness of these cleaning events is deeply rooted in the very nature of Martian dust itself. Because Mars is so dry, this dust is not at all adhesive, unlike the dust on Earth, which often clings stubbornly to surfaces due to humidity or static electricity. Martian dust is loose, almost ethereal. It doesn't stick stubbornly. It merely rests. And the dust is so incredibly fine, almost as fine as cigarette smoke, that it requires very little force to dislodge it. It doesn't take much at all to shift it off. A gentle puff of wind can do what no human hand can. This unique property of Martian dust, combined with the planet's occasional atmospheric whims, provided a lifeline for opportunity, a recurring renewal of its vital energy. You can actually observe this cleaning process happen over time, a subtle dance of particles and light that speaks volumes about the Martian environment. If you were to observe a time-lapse of the rover's camera views, watching days turn into weeks, you would witness a fascinating transformation. Look at this fleck of dirt here, a seemingly permanent blemish on the camera lens, a stubborn smudge obscuring a portion of the view. And then, as the days unfold, observe how it disappears over time. It's a quiet, almost imperceptible triumph, a testament to the persistent cleansing power of the Martian wind. Opportunity, unlike its more advanced successors, doesn't have a means of clearing this dust off by itself. It has always relied on these cleaning events, happening a profound dependence on the unpredictable generosity of the Martian atmosphere. And thankfully, over the course of its incredible 15-year mission, they did numerous times, acting as vital unsung heroes in its prolonged survival, allowing it to continue its silent vigil on the red planet. However, the enduring journey of opportunity was not without its trials, its moments of quiet struggle against the inexorable wear of time and the harshness of an alien environment. Sadly, amidst its continued resilience and the occasional grace of Martian winds during its long stay at Erebus, our intrepid rover encountered its first mechanical fault. This was not a sudden dramatic collapse, but a more subtle, persistent challenge, a quiet weakening of its vital parts. Its arm was getting stuck all the time. Imagine a limb once agile and responsive, now reluctant to obey resisting movement, a robotic protest against unseen forces. Through careful diagnosis, the engineers back on Earth, those distant physicians of the robot, identified the subtle culprit. There was a broken wire, a tiny yet critical break in the electrical connection that powered the arm's delicate movements. This small disruption had profound consequences. Although the motor still worked if it was given more power, it was a clear sign of strain, a whisper of impending weakness that could not be ignored. It meant that the arm, a key tool for its scientific endeavors, was no longer reliably responsive, posing a significant hurdle to its mission. After careful deliberation, a meticulous process of remote diagnosis and thoughtful debate, the engineers decided on a pragmatic and protective course of action. The best thing to do, they concluded, would be to only stow the arm away while traveling long distances. This minimized the stress on the weakened wire and the struggling motor during periods of extended motion. For shorter, more controlled movements, where the risk of full retraction was less critical, it would be kept in a hover stow position. Imagine a gentle compromise, the arm not fully retracted, but bent back at the elbow, held in a stable, less strained posture. This strategic adaptation required meticulous testing. Picture a replica of opportunity here on Earth, its arm held in this precise hover stow position, being used to test how it can travel with the arm out. The engineers were meticulously verifying that this new configuration would not impede the rover's movement or compromise its stability. Their reasoning was profound and practical. They thought it would be better to have the arm stuck while it was out, rather than to try and stow it away to find it can never be used again. At least in the hover stow position, it would be somewhat functional, still capable of minor adjustments and observations, allowing the mission to continue, albeit with a new subtle limitation. It was a testament to their dedication, finding a way to coax continued service from a struggling limb, ensuring that every precious moment of Opportunity's life on Mars was maximized for discovery. The silent battle against mechanical wear and tear continued for Opportunity, a persistent undercurrent in its grand narrative. Over the course of the mission up until this point, another subtle yet significant problem had been encountering a problem with a heater for a motor in the arm that wouldn't turn off. Imagine a tiny perpetually burning ember silently draining precious power from the rover's limited energy reserves. Engineers, with their characteristic ingenuity and remote persistence, managed to find a temporary yet clever workaround. They managed to get away with switching it off with a T-stat switch, a kind of thermal switch that would automatically cut power to the heater if the motor got too hot. It was an elegant, almost invisible solution, an automatic thermostat for a robotic limb preventing overheating. However, as Martian winter drew near, bringing with it shorter days and lower sun angles, the energy equation for our solar-powered rover shifted dramatically. There would be less sunlight, meaning the solar panels, even when clean, would generate less power. And critically, there simply wasn't enough power to have the heater on all night without severely depleting Opportunity's precious batteries. This posed a significant threat to the motor itself, as extreme cold could cause irreparable damage to its delicate components. To address this looming threat, the engineers implemented a more drastic yet necessary measure. They fixed this by completely disconnecting the batteries at night. It was a bold, almost desperate move, sacrificing continuous power flow to protect the vital circuitry from the brutal Martian cold. This solution, while protecting the batteries inadvertently, led to another equally challenging problem. With the batteries disconnected, there would now be very, very big swings in temperature between day and night. At the Martian equator, where Opportunity roamed, temperatures could oscillate wildly from up to 20 degrees Celsius during the day to a bone-chilling 75 degrees Celsius at its coldest at night. Imagine the profound thermal stress on a delicate motor repeatedly enduring such extreme cycles of expansion and contraction. This drastic temperature variability, compounded by Mars's incredibly thin atmosphere, meant that the motor would likely wear out faster. The reason for this extreme temperature variability is that although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. It was a constant, relentless battle against the fundamental thermal challenges of an alien world, a quiet testament to the resilience required for survival, and the persistent struggle with this particular motor culminated in a more significant setback. At this point in the mission, after enduring countless thermal cycles and prolonged stress, this motor stalled altogether. Imagine the quiet alarm back on Earth, the sudden cessation of function, a robotic limb rendered immobile. Engineers, those tireless problem solvers, found a temporary fix, a way to coax life back into the dormant component by applying more current through the motor. It was a forceful, yet necessary intervention, a way to override the failing connection and restore some semblance of movement. However, as a precautionary measure, mindful of the motor's increasing unreliability and the ever-present threat of permanent failure, they stowed the arm outside the rover at night in case the motor permanently stalled. This position, visible to the cameras and external observers, would allow them to attempt repairs or further analysis even if full functionality was irrevocably lost. It was a strategic retreat, a way to manage the risk. You'll start to notice this in the camera view from now on. A subtle yet persistent change in Opportunity's outward appearance, its robotic arm held in a bent, slightly extended posture. It became a visible mark of its long, challenging, and remarkably enduring journey. Each scar and workaround a testament to its incredible longevity and the unwavering dedication of its human partners, adapting to every twist and turn of its silent, epic voyage. By February 2006, or Sol 744, Opportunity had reached another significant landmark in its extended mission. Our diligent rover visited its last site around Erebus Crater, a specific geological feature named the Pacon outcrop. Imagine a small, unassuming rise in the terrain, yet holding within its very structure profound insights into Mars's ancient past. This outcrop, characterized by its fine layers, presented a fascinating geological puzzle. It showed a diverse range of primary and secondary sedimentary textures formed billions of years ago. Picture delicate stratified patterns laid down over immense spans of time, each layer, whispering tales of bygone eras. The structures observed here were particularly intriguing. They were likely caused between a mix of wind and water processes. Imagine a dynamic interplay, ancient winds sculpting the landscape, leaving their characteristic imprints, and then, at different times, the gentle or forceful flow of water, subtly reshaping and redepositing sediments. This intermingling of forces created a complex layered narrative within the rock, suggesting a Mars that was not static, but subject to diverse environmental influences. It was a testament to the planet's long active geological history, a grand story etched in stone, patiently waiting for opportunity's discerning eye to decipher, and so with its comprehensive survey of the Erebus region. Complete opportunity, with its tireless determination, prepared for its next grand voyage. By Sol 766, it had left the rim of Erebus and was on its way to the biggest and most impressive Mars crater, yet Victoria. This new destination promised to be a profound and challenging chapter in its epic journey, a geological wonder of immense proportions. The path to Victoria was not without its own unique challenges. Opportunity journeyed through large ripple sand dunes, a type of dune that, intriguingly, we don't have on Earth. Imagine vast undulating seas of sand sculpted into distinctive wave-like patterns. By the Martian winds, a silent alien ocean of grains. However ever prudent and focused on its scientific objectives, Opportunity tried to stick to paths of exposed bedrock, as these are much easier to traverse. Solid rock offered a stable, predictable surface for its wheels, minimizing the risk of getting mired in loose sand. And crucially, it allowed the rover to stop and investigate along the way, pausing its journey to examine any intriguing geological features it encountered. These cobblefields, patches of rounded stones scattered across the landscape, were a particular mystery. We are unsure how they formed like this, adding another layer of quiet wonder to the Martian puzzle. Each step of Opportunity's journey was not just about reaching a destination, but about continually observing, questioning, and gathering new insights from the enigmatic red planet. But even with the most careful planning and the most advanced software, the Martian landscape held its own surprises. On Sol 833, a day etched with a familiar anxiety, Opportunity almost got stuck again. The ghost of Purgatory Dune, though banished by new software, still whispered its warnings. Previously, mission controllers had been thrilled by the consistent, steady meters of progress per day Opportunity had been making towards Victoria. Each day's telemetry brought news of significant forward movement, a testament to the rover's renewed efficiency. But in this particular sequence of events, the struggle was palpable. It took 4 days to get out of this dune, a slow grinding battle against the unyielding sand. This stubborn grasping dune was given a fittingly evocative name, Jabuk, a Danish term meaning the Bay of Wailing, perhaps evoking the struggle of a ship caught in a powerful unseen current. Yet despite this momentary setback, the momentum of its grand journey was undeniable. Nearly 200 Martian days after it had left Erebus, a testament to the vast distances it had traversed, and the deliberate pace of its exploration, Opportunity finally arrived at Victoria. And what it saw was nothing short of amazing. Imagine standing at the edge of a colossal ancient bowl, its sheer scale breathtaking. It presented a high ridge wall, a towering majestic rim, a steep slope in inviting descent into its depths, and beautiful sand dunes in the center sculpted into graceful patterns by the unseen hand of the Martian wind. It was a panorama of immense geological grandeur, a silent, awe-inspiring amphitheater of time. Our little rover had already overcome so many obstacles in its long journey across the Meridiani Plains, and this magnificent sight, this immense geological wonder, was the reward at the end, a testament to its unwavering persistence and the boundless curiosity of its human creators. The secrets of Victoria, ancient and profound, now awaited its gentle metallic touch as opportunity. Now a more seasoned traveler approached Erebus Crater, a new chapter in its enduring journey began to unfold, revealing landscapes previously hidden beneath vast expanses of dust. Our little rover came upon sections of ground where the bedrock was exposed, vast ancient expanses of solid rock that seemed to whisper tales of geological time. Mission controllers, with a gentle touch of poetic whimsy, named this particular section the Erebus Highway. Imagine a natural roadway not paved by human hands, but forged by the slow, inexorable forces of the Martian past, inviting opportunity to traverse its unyielding surface. As we know, Opportunity's main mission, the very purpose for its journey across millions of miles, was to search for signs of water on Mars, and the most eloquent clues of water's ancient presence can often be found in the planet's rocks. These stoic witnesses hold within their very structure the telltale signatures of past interactions with liquid. To unlock these secrets, Opportunity once again deployed its diligent rock abrasion tool rat, using it to carve circles into the bedrock. This wasn't a destructive act, but a meticulous peeling back of layers, a gentle incision into the planet's skin, revealing the pristine rock beneath untouched by the long exposure to the elements. And with its microscopic camera, a tiny powerful eye on its robotic arm, it meticulously compared the different structures of the rock to search for evidence of water. Imagine the subtle variations it observed, the size and shape of individual grains, the way they were cemented together, the presence of tiny voids, or the subtle glimmer of mineral deposits. Each tiny detail was a whisper from the past, a clue in the grand narrative of Mars's hydrological history. These were not mere pictures. They were scientific interrogations, each image a question posed to the ancient stones, seeking the quiet echoes of water, waiting for the patient interpretation of distant human minds. You'll notice by now that the Opportunity's tracks are often in front of the rover in these images. This might seem like a curious detail, a subtle shift in perspective. Indeed, this is still the front camera viewing the path ahead, capturing the landscape before the rover's gentle passage, but sometimes in a testament to the ingenuity and resourcefulness of its human handlers. Mission controllers drove Opportunity backwards to even out the wear and tear on the equipment. Think of it as rotating the tires of a car, a simple yet profoundly effective way to extend the lifespan of this invaluable distant explorer. It's a quiet reminder that even millions of miles away, the principles of careful stewardship apply, ensuring that every precious component of the rover serves its purpose for as long as possible, meticulously extending its fragile existence. Erebus itself was a fascinating, though subtly disguised, geological feature. It was described as a very old and eroded crater, filled with sand with only a few outcrops showing. Imagine an ancient, once grand amphitheater, now largely filled in and smoothed over by the relentless passage of time and the ceaseless work of Martian winds. From the ground perspective, it might be difficult to even discern its true nature. You may not have been able to tell it's a crater from the ground perspective because it's so shallow and eroded. Its full vast circularity, its ancient contours only truly become visible, its true dimensions revealed from the satellite photos taken from orbit, a testament to the different scales at which we perceive the Martian landscape, a hidden grandeur only visible from a cosmic vantage point. This ancient weathered bowl was about twice as big as Endurance Crater at 350 meters in diameter. Yet surprisingly, Opportunity never actually went inside the crater, as there was only more dunes in it. The flat sand-filled basin, though vast, offered little in the way of exposed bedrock, the prime target for Opportunity's geological quest. Instead, our cautious rover stuck to the rim, avoiding larger dunes as it went. This was a strategic decision prioritizing scientific return and rover safety over the mere act of entering a new, if less fruitful, depression. The lessons of Purgatory Dune, though difficult, lingered a quiet reminder of the perils of soft, treacherous sands. Even while carefully maneuvering around these dunes, the Martian terrain continued to present its subtle, unexpected challenges. Opportunity, despite its enhanced software, its newly acquired wisdom, hit some soft sand and its wheel sunk in. Imagine a momentary pause, a subtle lurch, as the wheel found less firm purchase. But this time, something truly remarkable occurred. Luckily, the software that was installed only a few weeks previously noticed that the wheels were slipping and it stopped its drive command. This wasn't human intervention in real time. It was the machine's own nascent intelligence at work, a silent guardian protecting itself from harm, learning from past trials. You see, opportunity is not controlled in real time by a person on Earth with a joystick. The sheer distances involved make such direct control utterly impossible. There is too much latency for this, between 6 minutes to 40 minutes depending on the proximity of Earth and Mars. Imagine the frustration of trying to drive a remote-controlled car with a delay of many minutes. It would be an exercise in futility, a slow, unresponsive dance. So instead, opportunity is given drive commands, using these same navigational images you see here, and comparing it with satellite-based imagery. It's a painstaking process. Mission Controller's command, opportunity to drive forward a certain distance. Then it will take a new photo to show its progress, waiting for the human eye to confirm its path before the next set of instructions can be relayed across the cosmic void. The genius of the software that prevented opportunity from getting stuck lay precisely in this autonomy, this subtle leap in machine intelligence. It meant that mission controllers could get the rover to reverse out without another several-week delay, as had happened at Purgatory Dune. The machine had become a little bit wiser, protecting itself from repeating past mistakes. This subtle yet profound leap in autonomous capability was a quiet triumph, freeing up precious time for more scientific exploration, for deeper insights into the Martian past. During Opportunity's time near Erebus, it also embarked on a remarkable collaboration, a silent dialogue across the Martian sky. It collaborated with ESA's Mars Express Orbiter. Imagine two very different eyes, one on the surface, meticulously examining the tangible details of the terrain, and one orbiting high above, seeing the broad sweeping patterns of the planet. The Mars Express Orbiter images the surface of Mars from orbit to search for different types of materials without actually sampling the surface. It sees the broad strokes, the vast patterns, the subtle chemical signatures from afar. The data it collects, while invaluable, can be hard to interpret in isolation, a tapestry woven with threads of uncertainty. Opportunity, however, with its direct, tangible presence on the ground, could provide the crucial ground truth. It can physically interact with the surface material, confirming whether what the Mars Express data showed was correct or not. Imagine the orbiter seeing a faint whisper of a particular mineral from high above, a tantalizing hint, and then Opportunity carefully approaching that very spot, touching it, analyzing it with its instruments, and confirming its composition. This collaborative dance, this synergy of perspectives, was essential, helping them to refine their future observations, sharpening the vision of both perspectives, weaving together a more complete tapestry of Martian understanding, a dialogue between the sky and the ground. While Opportunity was still meticulously making its way around Erebus crater, patiently reading the ancient script of its rocks, the Martian atmosphere decided to put on a dramatic show. A big dust storm hit, a swirling tempest of fine crimson particles rising from the surface to engulf the sky. For a few days, as the storm intensified, Opportunity went dark, its signals falling silent, swallowed by the vast opaque veil of dust. Imagine the quiet anxiety back on Earth, the collective holding of breath as their distant emissary ceased its communications, its status unknown in the swirling chaos. And in a very interesting way, the event offered a subtle yet profound insight into the storm's impact. You could visibly see the difference the dust storm made to the rover as the camera goes from having a clear image to having some dust particles visible. It was like watching a subtle, insidious shroud slowly descend, gradually obscuring the clear vision. Also, the most immediate and critical impact of such a storm is that dust settles on the solar panels like a blanket, slowly dimming a light. This meant that Opportunity can't generate as much electricity, its lifeblood slowly being choked by the accumulating particles. It was a stark reminder of the fragile balance upon which its very existence depended, a constant vulnerability to the unpredictable whims of Mars. Very fortunately, though Mars, in its unpredictable wisdom, has occasional cleaning events. Think of these as nature's gentle touch, a spontaneous act of renewal that often extended the lives of our solar-powered explorers beyond all reasonable expectation. These are moments when the Martian atmosphere, in a subtle dance of currents and pressures, orchestrates a profound cleansing. Wind, or even a dust devil, a miniature whirlwind of Martian air, would pass over the rover, blowing the dust off the solar panels and camera. Imagine these ethereal swirling columns of air, like benevolent spirits, gracefully sweeping across the landscape, meticulously dusting off the precious instruments. It's a remarkable, almost poetic intervention, a testament to the unexpected kindness of an otherwise harsh environment, a quiet cooperation between machine and planet. The effectiveness of these cleaning events is deeply rooted in the very nature of Martian dust itself. Because Mars is so dry, this dust is not at all adhesive. Unlike the dust on Earth, which often clings stubbornly to surfaces due to humidity or static electricity, Martian dust is loose, almost ethereal. It doesn't stick stubbornly. It merely rests. And the dust is so incredibly fine, almost as fine as cigarette smoke, that it requires very little force to dislodge it. It doesn't take much at all to shift it off. A gentle puff of wind can do what no human hand can. This unique property of Martian dust, combined with the planet's occasional atmospheric whims, provided a lifeline for Opportunity, a recurring renewal of its vital energy, a quiet blessing from the red planet itself. You can actually observe this cleaning process happen over time, a subtle dance of particles and light that speaks volumes about the Martian environment. If you were to observe a time-lapse of the rover's camera views, watching days turn into weeks, you would witness a fascinating transformation. Look at this fleck of dirt here, a seemingly permanent blemish on the camera lens, a stubborn smudge obscuring a portion of the view. And then, as the days unfold, observe how it disappears over time. It's a quiet, almost imperceptible triumph, a gradual clearing of the view, a testament to the persistent cleansing power of the Martian wind. Opportunity, unlike its later successors, doesn't have a means of clearing this dust off by itself. It has always relied on these cleaning events, happening a profound dependence on the unpredictable generosity of the Martian atmosphere. And thankfully, over the course of its incredible 15-year mission, they did numerous times, acting as vital unsung heroes in its prolonged survival, allowing it to continue its silent vigil on the red planet. Sadly, however, amidst its continued resilience and the occasional grace of Martian winds, Opportunity began to encounter the inevitable wear and tear of a prolonged existence in a harsh alien environment. During its time at Erebus, the intrepid rover encountered its first mechanical fault. This was not a sudden dramatic collapse, but a more subtle, persistent challenge, a quiet weakening of its vital parts. Its arm was getting stuck all the time. Imagine a limb once agile and responsive, now reluctant to obey resisting movement. A robotic protest against unseen forces, a sign of the immense strain endured. Through careful diagnosis, the engineers back on Earth, those distant physicians of the robot, identified the subtle culprit. There was a broken wire, a tiny yet critical break in the electrical connection that powered the arm's delicate movements. This small disruption had profound consequences. Although the motor still worked if it was given more power, it was a clear sign of strain, a whisper of impending weakness that could not be ignored. It meant that the arm, a key tool for its scientific endeavors, was no longer reliably responsive, posing a significant hurdle to its mission, a limitation that required careful navigation. After careful deliberation, a meticulous process of remote diagnosis and thoughtful debate, the engineers decided on a pragmatic and protective course of action. The best thing to do, they concluded, would be to only stow the arm away while traveling long distances. This minimized the stress on the weakened wire and the struggling motor during periods of extended motion, protecting its fragile integrity. For shorter, more controlled movements, where the risk of full retraction was less critical, it would be kept in a hover stow position. Imagine a gentle compromise. The arm not fully retracted but bent back at the elbow, held in a stable, less strained posture, a subtle act of preservation. This strategic adaptation required meticulous testing. Picture a replica of Opportunity here on Earth, its arm held in this precise hover stow position, being used to test how it can travel with the arm out. The engineers were meticulously verifying that this new configuration would not impede the rover's movement or compromise its stability. Their reasoning was profound and practical. They thought it would be better to have the arm stuck while it was out, rather than to try and stow it away to find it can never be used again. At least in the hover stow position, it would be somewhat functional, still capable of minor adjustments and observations, allowing the mission to continue, albeit with a new subtle limitation. It was a testament to their dedication, finding a way to coax continued service from a struggling limb, ensuring that every precious moment of Opportunity's life on Mars was maximized. For Discovery, a silent act of perseverance. The challenges to Opportunity's mechanical well-being were not isolated. Over the course of the mission up until this point, another persistent problem had begun to emerge, a subtle battle against the biting Martian cold. It was encountering a problem with a heater for a motor in the arm that wouldn't turn off. Imagine a tiny, perpetually burning ember, silently draining precious power from the rover's limited energy reserves, a hidden inefficiency. Engineers, with their characteristic ingenuity and remote persistence, managed to find a temporary yet clever workaround. They managed to get away with switching it off with a T-stat switch, a kind of thermal switch that would automatically cut power to the heater if the motor got too hot. It was an elegant, almost invisible solution, an automatic thermostat for a robotic limb preventing overheating. However, as Martian winter drew near, bringing with it shorter days and lower sun angles, the energy equation for our solar-powered rover shifted dramatically. There would be less sunlight, meaning the solar panels, even when clean, would generate less power. And critically, there simply wasn't enough power to have the heater on all night without severely depleting Opportunity's precious batteries. This posed a significant threat to the motor itself, as extreme cold could cause irreparable damage to its delicate components. To address this looming threat, the engineers implemented a more drastic, yet necessary measure. They fixed this by completely disconnecting the batteries at night. It was a bold, almost desperate move, sacrificing consistent power flow to protect the vital circuitry from the brutal Martian cold. This solution, while protecting the batteries, inadvertently led to another equally challenging problem. With the batteries disconnected, there would now be very, very big swings in temperature between day and night. At the Martian equator, where Opportunity roamed, temperatures could oscillate wildly from up to 20 degrees Celsius during the day to a bone-chilling 75 degrees Celsius at its coldest at night. Imagine the profound thermal stress on a delicate motor, repeatedly enduring such extreme cycles of expansion and contraction. This drastic temperature variability, compounded by Mars's incredibly thin atmosphere, meant that the motor would likely wear out faster. The reason for this extreme temperature variability is that although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. It was a constant, relentless battle against the fundamental thermal challenges of an alien world, a quiet testament to the resilience required for survival. And the persistent struggle with this particular motor culminated in a more significant setback. At this point in the mission, after enduring countless thermal cycles and prolonged stress, this motor stalled altogether. Imagine the quiet alarm back on Earth, the sudden cessation of function, a robotic limb rendered immobile. Engineers, those tireless problem solvers, found a temporary fix, a way to coax life back into the dormant component by applying more current through the motor. It was a forceful, yet necessary intervention, a way to override the failing connection and restore some semblance of movement. However, as a precautionary measure, mindful of the motor's increasing unreliability and the ever-present threat of permanent failure, they stowed the arm outside the rover at night in case the motor permanently stalled. This position, visible to the cameras and external observers, would allow them to attempt repairs or further analysis, even if full functionality was irrevocably lost. It was a strategic retreat, a way to manage the risk. You'll start to notice this in the camera view from now on. A subtle yet persistent change in Opportunity's outward appearance, its robotic arm held in a bent, slightly extended posture. It became a visible mark of its long, challenging, and remarkably enduring journey. Each scar and workaround a testament to its incredible longevity and the unwavering dedication of its human partners, adapting to every twist and turn of its silent, epic voyage. By February 2006, or Sol 740 year, Opportunity had reached another significant landmark in its extended mission. Our diligent rover visited its last site around Erebus crater, a specific geological feature named the Pacon outcrop. Imagine a small, unassuming rise in the terrain, yet holding within its very structure profound insights into Mars's ancient past. This outcrop, characterized by its fine layers, presented a fascinating geological puzzle. It showed a diverse range of primary and secondary sedimentary textures formed billions of years ago. Picture delicate stratified patterns laid down over immense spans of time, each layer, whispering tales of bygone eras, a silent chronicle of the planet's distant youth. The structures observed here were particularly intriguing. They were likely caused between a mix of wind and water processes. Imagine a dynamic interplay, ancient winds sculpting the landscape, leaving their characteristic imprints, and then, at different times, the gentle or forceful flow of water, subtly reshaping and redepositing sediments. This intermingling of forces created a complex layered narrative within the rock, suggesting a Mars that was not static, but subject to diverse environmental influences. It was a testament to the planet's long active geological history, a grand story etched in stone, patiently waiting for Opportunity's discerning eye to decipher, to unravel the subtle dance of wind and water across a world now parched and silent. And so, with its comprehensive survey of the Erebus region, complete, Opportunity, with its tireless determination, prepared for its next grand voyage. By Sol 766, it had left the rim of Erebus and was on its way to the biggest and most impressive Mars crater yet, Victoria. This new destination promised to be a profound and challenging chapter in its epic journey, a geological wonder of immense proportions. The path to Victoria was not without its own unique challenges. Opportunity journeyed through large ripple sand dunes, a type of dune that, intriguingly, we don't have on Earth. Imagine vast undulating seas of sand, sculpted into distinctive wave-like patterns by the Martian winds, a silent alien ocean of grains, stretching endlessly towards the horizon. However, ever prudent and focused on its scientific objectives, Opportunity tried to stick to paths of exposed bedrock, as these are much easier to traverse. Solid rock offered a stable, predictable surface for its wheels, minimizing the risk of getting mired in loose sand, ensuring a smooth and safe passage. And crucially, it allowed the rover to stop and investigate along the way, pausing its journey to examine any intriguing geological features it encountered, extracting every possible whisper of knowledge from the landscape. These cobble fields, patches of rounded stones scattered across the landscape, were a particular mystery. We are unsure how they formed like this, adding another layer of quiet wonder to the Martian puzzle, a subtle enigma waiting to be unraveled. Each step of Opportunity's journey was not just about reaching a destination, but about continually observing, questioning, and gathering new insights from the enigmatic red planet, a tireless quest for understanding. But even with the most careful planning and the most advanced software, the Martian landscape held its own surprises. On Sol 833, a day etched with a familiar anxiety, Opportunity almost got stuck again. The ghost of Purgatory Dune, though banished by new software, still whispered its warnings, a subtle reminder of the landscape's inherent treachery. Previously, mission controllers had been thrilled by the consistent, steady meters of progress per day Opportunity had been making towards Victoria. Each day's telemetry brought news of significant forward movement, a testament to the rover's renewed efficiency. But in this particular sequence of events, the struggle was palpable. It took 4 days to get out of this dune, a slow, grinding battle against the unyielding sand, a test of both machine and human patience. This stubborn, grasping dune was given a fittingly evocative name, Jabuk, a Danish term meaning the Bay of Wailing, perhaps evoking the struggle of a ship caught in a powerful unseen current, fighting to break free. Yet, despite this momentary setback, the momentum of its grand journey was undeniable. Nearly 200 Martian days after it had left Erebus, a testament to the vast distances it had traversed and the deliberate pace of its exploration, Opportunity finally arrived at Victoria. And what it saw was nothing short of amazing. Imagine standing at the edge of a colossal ancient bowl, its sheer scale breathtaking. It presented a high ridge wall, a towering, majestic rim stretching across the horizon, a steep slope, an inviting descent into its depths, hinting at hidden layers, and beautiful sand dunes in the center sculpted into graceful patterns by the unseen hand of the Martian wind, a silent, artistic centerpiece. It was a panorama of immense geological grandeur, a silent, awe-inspiring amphitheater of time. Our little rover had already overcome so many obstacles in its long journey across the Meridiani Plains, each one a testament to its resilience, and this magnificent sight, this immense geological wonder, was the reward at the end, a testament to its unwavering persistence and the boundless curiosity of its human creators. The secrets of Victoria, ancient and profound, now awaited its gentle metallic touch, ready to yield their timeless narratives. So what was so interesting about Victoria Crater? This vast ancient bowl, now bathed in the soft Martian light, held promises that beckoned Opportunity with an almost magnetic pull. Was it able to provide any valuable information about Mars that Opportunity hadn't picked up anywhere else? The answer, woven into the very fabric of its existence, was a resounding yes. Victoria was always going to be an important landmark for Opportunity to reach a crucial waypoint in its grand Martian saga. Few, if any, truly thought Opportunity would last the 7-kilometer journey from its initial landing site at Eagle Crater to the distant, beckoning rim of Victoria. It was a trek of immense proportion for such a tiny, delicate machine, and yet, here it was. At this point, Opportunity had lasted more than 10 times longer than its original design lifespan. Think of that, a machine built for a brief 90-sol sprint, now embarking on a marathon of epic proportions, a testament to both its robust engineering and the unwavering dedication of the human minds guiding it. Victoria itself was the biggest crater Opportunity had visited yet, being 730 meters wide. Imagine a colossal amphitheater, its sheer scale dwarfing our tiny explorer. It was also the deepest crater it had encountered, meaning ancient bedrock outcrops along the walls of the crater were exposed to the surface. These deep exposed layers of bedrock were the very clues to Mars's past that Opportunity was looking for, like the oldest, most profound pages in a forgotten book. Also, as you can see, Victoria made for an impressive sight, especially in contrast to this otherwise flat, seemingly featureless plain that Opportunity had landed in. It was a dramatic punctuation mark in the vast, subtle landscape of Meridiani Planum, a visual reward for a journey of immense patience and perseverance. In preparation for this new grand exploration site, a significant step was taken by the mission controllers. They uploaded new software to the rover, a subtle yet profound enhancement to Opportunity's very intelligence. This new programming would enable it to decide whether to send back an image or to extend its arm in preparation to sample an interesting rock outcrop. Imagine the rover gaining a deeper level of autonomy, a more nuanced understanding of its own scientific priorities. It also aimed to improve the intelligence of the rover, to detect obstacles it should avoid, and to make its own path around them. This was a leap towards greater independence, reducing the need for constant laborious human intervention. Think of the immense effort this new software was designed to alleviate. Without it, human controllers would have had to have gone through hundreds of images and wait through painful latency delay for commands to be sent to the rover. At its furthest point, the latency, the time it takes for a signal to travel from Earth to Mars and back, can be upwards of 40 minutes. Imagine the immense patience required, the slow, deliberate dance of remote control. This colossal delay is one of the very reasons why it had taken 3 years to only travel 7 kilometers up until this point. The new software was a gift of time and autonomy, designed to accelerate the pace of discovery. To test this vital new software update, the mission controllers devised a clever, cautious experiment. They had Opportunity drive towards a patch of rubble. Seemingly insignificant stones and settings were adjusted to make Opportunity think that this rubble was a no-go zone. It was a gentle deception designed to gauge the rover's autonomous response. In reality, the biggest of these rocks was only 10 centimeters tall, meaning Opportunity could have easily driven over it without any issue. But they didn't want to test the systems on something that could actually damage the rover if it went wrong. The stakes were too high, the rover too precious. So they wisely chose these smaller benign rocks instead, a safe arena for a critical test. As expected, the new software proved its worth. As you can see, the rover adjusted its course around the dangerous area, gracefully navigating the simulated hazard with its newfound intelligence. And as it did so, it took this panorama so mission controllers could see how the rover responded to the new program, confirming its successful integration and demonstrating its enhanced capabilities. It was a quiet triumph, a validation of months of painstaking work by engineers millions of miles away, ensuring that Opportunity was now even more adept at traversing the subtle dangers of the Martian landscape. Opportunity began its exploration of Victoria Crater, not by plunging directly into its depths, but by a meticulous panoramic survey of its periphery. It began to circle the outskirts of the crater, imaging it as it went. Imagine a tiny 6-wheeled artist slowly tracing the grand contours of an ancient masterpiece, capturing its every detail. As it navigated the rim, it came across a few cliffs or capes along the way, prominent geological features rising majestically from the crater walls. It began imaging them with a very clever technique called a super-resolution mosaic. This wasn't just a simple photograph. It was a sophisticated composite, a method designed to extract maximum detail from its limited optical instruments. These images, remarkably, have a much higher resolution than the camera on board Opportunity is capable of in a single shot. And the ingenious way they achieved this was by taking lots of photos of the same thing from slightly different angles, capturing minute variations in light and shadow. Then, in a process of meticulous artistry and scientific precision back on Earth, they combined the images to provide the resolution you see here. It's like weaving many fine threads into a single rich tapestry, revealing details that would otherwise remain hidden. On a side note, this technique is used in many different fields, a testament to its fundamental power. It's employed including microscopy and astronomy, wherever the need to extract maximum detail from limited optical information arises. It speaks to the universal principles of data enhancement applied from the smallest biological structures to the grandest cosmic phenomena. Scientists poring over these super-resolution mosaics began to decipher the stories etched in Victoria's walls. They observed that the layers you see in the rocks found in all these cliff faces are due to a geological process called crossbedding. This wasn't a random pattern. It was a distinctive signature, a silent testament to ancient forces. They believe these layers are ancient sand dune deposits, the petrified remains of vast shifting seas of sand long ago turned to stone. This is why the lines are inclined upwards, and not just horizontally, a telltale sign of deposition by wind or water currents, rather than tranquil, horizontal sedimentation. From these lines, these delicate whispers of geological history, they predict that this area used to be a sand dune field, not unlike the Sahara Desert on Earth. Imagine Mars billions of years ago, with vast undulating deserts, swept by ancient winds, a landscape strikingly familiar, yet profoundly alien. While this scientific data, this profound glimpse into Mars's ancient past, was immensely useful, the mission controllers had a more immediate practical objective. They were primarily looking for a passage down to the crater floor, a safe and accessible route to the deeper, more ancient layers that awaited below. They thought they found one promising candidate here, a seemingly gentle slope they named the Valley Without Peril. It held the promise of a direct route into the crater's heart. However, upon closer examination, after meticulous analysis of the topographical data and opportunities detailed imagery, it was decided that the slope was too steep. Despite its inviting name, the risk was still too high, the potential for entrapment too great. Opportunity, ever diligent, investigated a couple of cliffs while it was there gathering more precious data from the rim. It even came across another meteorite called Santa Catarina, another cosmic visitor, lying silently on the Martian surface, a serendipitous discovery in its tireless journey. But ultimately, with no safe path, apparent mission controllers made a difficult decision. They decided to drive the whole way back to the original arrival point at the crater to try and head down by there. It was a long detour, a step backward to ensure a safer path forward. This alternative site was chosen for several crucial reasons. Firstly, the slope was within the safety limits of the rover, a non-negotiable factor for such a vital piece of machinery. Secondly, and equally importantly, the ground was made of flat exposed bedrock, which meant it wouldn't have much wheel slippage. Solid, unyielding rock offered a stable grip, minimizing the risk of getting mired in loose sand. And so, with careful planning and remote guidance, on the 28th of June 2007, Orphemer 200 Souls into the mission opportunity prepared itself for its descent, poised at the edge of a new profound chapter in its long and storied exploration of Mars. But just as Opportunity perched itself on top of the slope, ready to descend into the depths of Victoria Crater, the Martian atmosphere decided to unleash a dramatic, unforeseen challenge. The biggest dust storm Opportunity had seen yet rolled in a vast, swirling tempest of crimson particles that seemed to engulf the entire planet. This wasn't a localized event. It was a formidable, widespread phenomenon, a true test of the rover's resilience. The immediate profound impact was a drastic reduction in sunlight, the storm decreasing the brightness of the sun by 96%. Imagine the Martian sky, usually a pale butterscotch hue, now turned into a deep, ominous twilight. The sun a mere ghost behind a thick, swirling veil. That profound dimming, however, was not quite as dire as it sounds in terms of immediate power generation. This is because the dust also scattered some of the sunlight towards the rover too, a diffuse illumination that provided a faint, indirect source of energy. Meaning even on the darkest day, Opportunity was still generating 128 watts, a remarkable feat given the storm's intensity. But this was a stark contrast to its usual 700 watts on a clear day, a significant and alarming drop. This profound reduction in power generation was bad news for a solar-powered rover. That kind of power level, anything under 150 watts, meant that the batteries, the rover's very lifeblood, begin to run flat. It was a critical threshold, a tipping point into a perilous state. As a result, operations were cut back substantially until the storm was over. Every non-essential activity ceased, and Opportunity was commanded to only communicate back to Earth once every 3 days instead of its usual daily check-ins. It was a measure of desperation, a quiet hope that by conserving every precious watt, the rover might just survive this unprecedented atmospheric assault. The greatest fear, the profound threat lurking beneath the surface of this power crisis, was the biting Martian cold. If the batteries did run flat, the components on board Opportunity could be damaged due to the intense cold on the planet during the night. Typically, the motors and other sensitive electronics have heaters powered by the batteries during the night to keep the motors warm. These heaters are vital for maintaining operational temperatures, preventing delicate parts from cracking or freezing. If the batteries ran flat, there would be nothing to stop there being extreme temperature differences between the night and day. At the Martian equator, these swings are immense, anything up to 20 degrees Celsius during the day and 75 degrees Celsius at its coldest at night, a brutal thermal cycle that could shatter components. The reason for this temperature variability is because although Mars does have an atmosphere, it is 100 times thinner than Earth's, meaning it is not anywhere near as good at retaining the heat it absorbs during the day. It's a leaky blanket, allowing the warmth of the sun to quickly dissipate into the vastness of space once night falls, going back to the batteries if they reached a critical level. Opportunity was also designed to trip a low-power fault. This was an automated self-preservation mechanism, a last resort to safeguard its vital systems. This basically disconnects the rover's batteries from all but the most essential systems of the rover, putting it to sleep as it tries to charge its batteries with whatever available sunlight there is every sol. It was a kind of robotic hibernation, a desperate attempt to gather enough energy to awaken again. The rover would then patiently check the battery level to see if it could reconnect the other systems, and if so, it would then re-establish communications with Earth, sending a faint whisper of its survival across the void. This low power mode could mean that the rover stays asleep for only a few days, but it could also go on for weeks or even months. And the profound silent fear was that even if it did switch back on, chances are at that point, too many of its components would be broken and it wouldn't be able to function anyway. It was a race against time, a battle for life itself, shrouded in the crimson dust. Back to the dust storm itself, which began its ominous advance at the start of July 2007. Mission controllers initially harbored a quiet hope that it would only last a week. They had seen dust storms before, localized phenomena that eventually dissipated. But this one was different, a monster growing in scale and intensity. By the 15th of July, the storm had reached its peak, a truly global event engulfing the entire planet in a thick, opaque shroud. These are true color images showing a time-lapse of the storm. And as you can see, it does get very dark, the sunlight almost entirely obliterated by the suspended dust. Thankfully, the severity of the dust storm, though terrifyingly close, was not quite enough to trigger the low-power fault this time. Opportunity, against all odds, managed to cling to enough residual power to avoid total system shutdown. Although it did get worryingly close for a while, teetering on the brink of hibernation, the diligent power management and the subtle scattering of light allowed it to endure. Eventually, by the 21st of August, or for Sol, 71, after enduring weeks of profound darkness and limited communication, the storm had cleared enough so that Opportunity could start to move forward again. It was a slow reawakening, a gradual return to light and activity, a testament to the rover's profound resilience in the face of nature's grandest challenges, with the worst of the dust storm behind it and the Martian sky slowly clearing. Opportunity, our resilient explorer, prepared to finally complete its intended descent into Victoria Crater. Sol 1291 saw Opportunity finally enter the slope of the crater its wheels gripping the ancient Martian rock with renewed purpose. But like it did before with the previous crater, in a testament to its acquired caution and the meticulous planning of its human guides, just after it entered it, backed out again to assess the amount of wheel slippage from the slope. It was a calculated risk, a quick test of the terrain's stability before committing to a deeper exploration. As it happened, the initial assessment revealed a challenge wheel slippage did exceed the mission controller's threshold of 40%. This was a significant amount, indicating that the ground was less firm than ideal and posing a risk of getting stuck. So, the rover, with its programmed caution, stopped with two of its wheels still over the lip of the crater. It was a precarious position, half in half out, a silent pause on the precipice of discovery. After 2 days of decision-making back on Earth, weighing the risks against the scientific rewards, mission controllers decided to press ahead regardless. The promise of Victoria's ancient layers, its profound secrets, was too compelling to abandon. And with that courageous decision, an extended exploration into the crater began in earnest. As opportunity descended, its methodical approach remained unwavering. It took some time to investigate any interesting-looking parts of the exposed bedrock, pausing to examine subtle features, reading the quiet stories etched in the stone. It also took some images of the cliffs on either side of it, capturing the majestic layered walls that surrounded its path. These images, more than mere data, painted a profound picture of its environment. I think these images show just how steep this slope that opportunity is sitting on, roughly 20 degrees, giving us a visceral sense of the challenges it was navigating. It was a testament to its climbing prowess and the careful guidance from Earth. Opportunity, with its scientific pragmatism, didn't venture too far into the crater, as only sand dunes were found towards the base. The primary objective was always bedrock, the solid canvas upon which Mars's ancient history was most clearly written. Instead, it spent its time examining this light patch of bedrock, a specific area of scientific interest. It meticulously taking various pictures and using its rock abrasion tool to investigate the rock structure. From the data Opportunity collected, it was determined that this area was likely not ever so hospitable to life. The chemical and geological signatures suggested conditions that were less conducive to the emergence or sustenance of organisms. And so, with this conclusion, a new target was identified, a new goal set for our intrepid explorer. Mission controllers picked the next waypoint on their journey, Endeavour Crater. If you thought Victoria was big, Endeavour was a true mammoth, a geological titan. It was thought to contain some clay-specific types of minerals that form in the long-term presence of water. Meaning water was once there, not just ephemerally, but for extended periods, perhaps even as vast, deep bodies. So, with this immense promise of profound discovery, Opportunity started its journey out of Victoria, leaving the ancient amphitheater behind and turning its tireless gaze towards the distant beckoning horizon of Endeavour, a new chapter in its extraordinary enduring saga. The red dust, ever present, continued to swirl softly in its wake, a silent witness to its tireless quest. The journey of Opportunity. Our tireless metallic companion was defined not just by the grand discoveries it made within the craters, but also by the vast, silent distances it traversed between them. As it began its long trek towards Endeavour Crater, a new challenge emerged, a quiet whisper of vulnerability. On Sol 1502, our resilient rover encountered another fault with its arm. This wasn't a new issue, but a recurrence, a persistent struggle against wear and tear. No matter how much power they put into the joint, the arm wouldn't move from its stow position under the rover. It was stubbornly stuck, a crucial limb, refusing to obey, threatening to halt its scientific endeavors. Sol after sol passed, and the joint refused to move, a frustrating silence from millions of miles away. The engineers back on Earth, those remote surgeons of the machine, meticulously analyzed the telemetry, searching for a solution. Eventually, after patient observation, they determined the time of day. The joint had the least electrical resistance, a subtle window of opportunity. This occurred just at dawn before the heater for the motor switched off during the day. It was a delicate balance of temperature and power, a fleeting moment of optimal conditions. When that precise time came, they put as much power as possible into the motor, and it worked. The arm, with a reluctant whir, finally moved, a small victory against mechanical entropy, not risking ever stowing it away, again a lesson learned from its previous struggles. Engineers had to determine how to maneuver the rover safely without risking damage to the arm. Its new extended position required careful consideration for every movement, every turn of the wheel. Opportunity then began its 2-year trek towards the Endeavour crater. Imagine the immense patience required for such a journey, a tortoise-like pace across an alien world, each kilometer a triumph of persistence. This is Endeavour crater, a true giant compared to the geological features Opportunity had explored thus far. It was a huge but shallow crater at 22 kilometers across and 300 meters deep. Its sheer scale alone was breathtaking, but why Endeavour crater? What made this distant, vast depression such a compelling, long-sought destination for Opportunity? Due to the distances involved, it would take a long time for Opportunity to get there, consuming precious years of its extended mission. So what was so special about this place compared to anything Opportunity had seen before? The most compelling reason, and indeed one of the fundamental science goals of Opportunity, was to find evidence of past oceans on Mars. This was the holy grail of Martian exploration, a profound question that had haunted scientists for decades. At this point in 2008, the theory that Mars once held a vast ocean on its surface was only just starting to get solid evidence, thanks in no small part to the collective efforts of the Spirit and Opportunity rovers. Opportunity, in its previous explorations, had indeed discovered that water once existed on the places it had visited, but these were no more than shallow floodplains, which dried up periodically, not a true enduring ocean. They hinted at a wetter past, but not a profound, deep one. On the other hand, the Mars Reconnaissance Orbiter MRO, that watchful eye from above, had spotted something truly tantalizing, what was believed to be clays around Endeavour crater. Clays, crucially, are hydrated minerals, which could have only formed from water, being on the surface for extended periods. Imagine water pooling, sitting interacting with the geology for vast spans of time, leaving behind these unique chemical signatures. Could Endeavour therefore have been part of a more permanent ocean? Could this vast basin hold the key to understanding Mars's true hydrological past? And if there really was a surface ocean, a vast body of liquid water, are there clues to indicate that it could have harbored life? These were the profound existential questions that propelled Opportunity forward. Mission controllers had to find out, for the answers could fundamentally reshape our understanding of not just Mars, but the very prevalence of life in the cosmos. And so, Opportunity left Victoria Crater and began its arduous journey south, a silent, resolute pilgrimage towards the promise of Endeavour. The mission team was fiercely determined to reach their destination as quickly as possible, knowing that Opportunity's prolonged lifespan was a precious gift that could end at any moment. Yet their scientific diligence remained paramount. They were also committed to keeping a lookout for anything of interest along the way. Opportunity made good time across the vast, flat expanse of the Meridiani Plains, its wheels diligently turning over countless sols. By Sol 1818, it had traveled more than 3 kilometers, a significant distance for a rover of its vintage, especially one that had already far exceeded its design life. Nothing noteworthy really happened for a long stretch, a period of quiet, steady progress across a seemingly uniform landscape, until Seoul 1947, when a large rock was spotted, an anomaly on the otherwise flat plain. The mission team, with their characteristic curiosity, decided to investigate, turning Opportunity's gaze towards this unexpected feature. And in doing so, they made another fascinating discovery. It was a meteorite, which they named Block Island. Imagine a piece of the cosmos having traveled untold distances, now resting silently on the Martian surface, waiting for an earthly emissary to examine it. In fact, large rocks seemed to be the only thing to keep Opportunity busy during this long, somewhat monotonous trek across the plains. These lone sentinels, scattered across the vastness, offered a welcome distraction and valuable scientific targets. Later, our rover spotted another one called Shelter Island, and then a third, even more intriguing, called Marquette Island. Marquette Island was of particular interest to scientists, though, as they believed this rock was part of the ejecta from a large meteor impact, meaning this rock would have come from deep in Mars's crust. Imagine the sheer force of a cosmic collision, powerful enough to excavate material from the very foundations of the planet, launching it across vast distances. Scientists could tell this profound origin story because the grains within the rocks are coarse with a basal composition. The coarseness indicates it cooled slowly for molten rock, allowing crystals time to grow. Had it formed near the surface, the crystals within it would have been a lot smaller, as it would have cooled a lot quicker. Each pebble, each grain, a silent storyteller of unimaginable cosmic events. Opportunity was never truly alone on Mars. It had a sister rover, a twin Spirit exploring the other side of the planet at the time. This was Spirit, which had landed roughly at the same time as Opportunity, its counterpart, in the Grand Martian duet. Both had far exceeded their original expected lifespan of 90 sols. At this point in their shared journey, they were 1,900 sols into the mission, a testament to their incredible durability and the dedication of their human teams. However, just like Opportunity had encountered its own trials, Spirit had encountered some mechanical failures too. Most notably, one of its front wheels jammed only 700 sols into its mission, a significant setback that drastically altered its mobility. This meant it dragged this wheel along as it traveled, leaving a distinctive linear track on the Martian surface, a visible sign of its quiet struggle. In a way, I almost think Spirit was NASA's darling between the two rovers. Spirit often got more media attention for the things it was discovering on the planet, perhaps for its more dramatic tales of survival. However, it was around the time Opportunity was meticulously exploring those intriguing rocks that Spirit, on the other side of the planet, faced its ultimate challenge. It attempted to drive over a sand dune and got its wheel stuck deeply in the sand. Imagine the quiet alarm, the sudden cessation of movement, the realization that this might be a final insurmountable obstacle. Spirit's operators back on Earth began the long, painstaking process of attempting to get it unstuck through simulations and testing on Earth-based replicas. It was a remote battle against an unyielding granular trap. Meanwhile, Opportunity, unaware of its sister's predicament, carried on its long journey to Endeavor, a lonely sentinel making its way across the vast Martian plains. By Sol 138. After an immense and patient journey, Opportunity finally reached a new landmark of note, Conception Crater. It was a relatively small feature, only 10 meters wide, but probably the youngest crater visited yet. Its youthful age was evidenced by the exposed rubble and ejecta, the fresh, unweathered debris scattered around its rim, a stark contrast to the ancient eroded features Opportunity had become accustomed to. Scientifically, however, nothing particularly new was found there compared to any of the bedrock Opportunity had examined in the past, which was simply sulfate-rich sandstone containing peppercorn-sized spheres known as blueberries. These blueberries, though fascinating in their own right, were a familiar geological feature to Opportunity. At least, the crater provided a visual contrast to the vast expanse of rolling sand dunes, a momentary break in the monotonous landscape, a small island of rocky texture in a sea of sand. Meanwhile, on the other side of the planet, the struggle to free Spirit continued, stretching into agonizing months. 8 months had passed since Spirit got stuck in the dune. The sand that enveloped its wheels was particularly fine, almost like talcum powder, offering little purchase. And the process of excavating Spirit was exasperated by its jammed wheel, making precise maneuvers even more challenging. During this incredibly difficult recovery process, another piece of devastating news arrived. Another of Spirit's wheels, jammed meaning only 4 of the 6 now worked. Its mobility, already severely compromised, was now even further diminished. The Martian winter, a season of dwindling sunlight, approached for Spirit. It was getting less and less sunlight to power its batteries, as the sun dipped lower in the sky and the days grew shorter. Until finally, the inevitable occurred. A low power fault occurred on the rover, and its systems disconnected from the battery. Spirit, its energy reserves depleted, went silent. Mission controllers, heartbroken but determined, attempted for months afterwards to regain contact with the rover, sending out silent calls across the cosmic void, hoping for a flicker of life. But after a long period of heartbreaking silence, NASA eventually called an end to Spirit's mission. For the first time since it landed, Opportunity was now truly alone on Mars, the last surviving twin, a solitary sentinel in the vast red desert. Opportunity's long, slow journey over kilometers of sand dunes to reach Endeavour was becoming increasingly taxing for the rover. The cumulative wear and tear, the subtle resistance of the terrain were beginning to show. Perhaps overly anxious not to have a repeat of what happened to Spirit, the tragic fate of its sister rover still fresh in their minds, mission controllers decided to route Opportunity's course, a longer route, but hopefully a less arduous one. It was a pragmatic decision, prioritizing safety and endurance over direct efficiency. This revised route would also take it by what was named Santa Maria Crater, offering another potential scientific stop along the way. By Sol 2244, Opportunity set a new profound record for endurance. It finally beat Viking 1's mission duration, becoming the longest-lasting mission on Mars. It was a testament to its incredible resilience, a quiet triumph in the face of countless challenges. As it pressed onward, Opportunity could begin to see the rim of Endeavour, a faint, distant line on the horizon, slowly resolving into discernible landmarks. It spotted the prominent features of Cape Tribulation, Cape Byron, and Cape Dromedary, named after famous terrestrial capes, a way to bring a familiar touch to this alien landscape. However, even 100 sols later, it was only halfway to Endeavour from Victoria. The sheer scale of the journey was immense, stretching over vast spans of Martian time. It had made good time, considering it has a top speed of 5 centimeters second, a pace that feels incredibly slow to human perception, and often went half of that to be safe. Caution was paramount, ensuring it avoided any sudden impacts or treacherous terrain. This slow pace also involved frequent stops to look out for potentially problematic sand dunes, its autonomous systems constantly scanning the path ahead. You'll notice the rover's tracks are ahead of the rover in this time lapse. This is because there is also a navigational camera on the back of Opportunity, allowing it to drive forwards or in reverse to evenly distribute wear and tear on the motors. Although another reason right now was to protect Opportunity's extended arm, which, as I mentioned, got stuck in this position. The ability to drive in reverse provided a crucial flexibility, allowing the rover to adapt to its mechanical limitations and prolong its operational life. On Sol 2449, Opportunity finally arrived at Santa Maria Crater. It was a 90-meter wide crater, a modest size compared to the giants it had visited. But it was important to mission controllers, as there was already evidence here of hydrated sulfate minerals. As I mentioned earlier, hydrated minerals can only form under bodies of water over extended periods of time, suggesting a more enduring presence of liquid water in this location. So this was an exciting precursor to what they really wanted to investigate around Endeavour, which was still a tantalizing 2-year journey away, a testament to the vastness of the Martian plains. Opportunity also stopped here to take a spectacular time-lapse of a Martian sunset or two. Imagine the reddish sun dipping below the crimson horizon, painting the sky in hues of ochre and deep violet, a serene moment of cosmic beauty. With one of the time-lapses showing a transit of Mars's biggest moon, Phobos, across the sun, a tiny dark silhouette moving silently across the solar disk. Over 2 years had passed in just this one episode, a testament to the slow, deliberate pace of deep space exploration. Opportunity had soldiered on well beyond its expected mission lifetime of 90 souls and even outlived its sister rover Spirit. It and the mission team had earned a rest at Santa Maria, and they all spent 3 months happily examining rocks and unlocking secrets about the history of Mars, a well-deserved pause in its epic journey. After that fairly uneventful, but scientifically productive 3 months, at the Santa Maria Crater Opportunity with renewed purpose, headed towards the closest hill on the crater rim known as Cape York. It was a new landmark, a new beacon guiding its prolonged journey. Along the way, it came across a few small craters, subtle depressions in the vast Martian plain. Some of these were very young with ejecta from the impact strewn across the place, indicating relatively recent cosmic collisions, fresh scars on the ancient surface. But Opportunity didn't stay for long. Its gaze was fixed on the greater promise of Endeavor. As Opportunity began approaching Endeavor, the landscape itself started to transform, a welcome change from the long stretches of flat plains. Our rover was finally able to see some variation in the landscape after years of simply crossing flat plains of sand dunes. The monotonous undulating seas of sand began to give way to more complex geological features. Peaks and capes started to rise up on the horizon, majestic formations, breaking the flat skyline, beckoning the rover towards a new, more diverse terrain. And so, with tireless determination, on Sol 2709 Opportunity finally arrived at Cape York, a significant milestone in its journey. More specifically, it reached a poignant location known as Spirit Point, named after Opportunity's sister rover, that had come to the end of its mission on the other side of the planet only a few months previously. It was a silent tribute, a commemoration of a lost companion, an acknowledgement of their shared epic journey. By this point, Opportunity had traveled over 30 kilometers up until this point, a staggering distance, 50 times further than the original planned mission distance. It was an accomplishment of immense proportion, a testament to its extraordinary longevity. Mission planners, having reached this long-sought destination, made a crucial decision. They decided not to go into the crater, as points of interest were again found around the rim of the crater. The most compelling scientific targets, the deepest secrets of Endeavor, were not necessarily within its vast basin, but rather along its periphery. Bedrock is exposed to the surface there, offering pristine, unweathered samples for analysis. This allowed Opportunity to study the oldest rocks it had seen so far on this journey, delving even deeper into Mars's ancient past, uncovering chronicles from billions of years ago. It was also around these peaks and capes along the rim where the hydrated minerals or clays were detected by the MRO, that watchful eye from orbit. This was the ultimate prize, the definitive evidence of long-term water interaction, confirming the immense value of this distant, challenging destination. Perched on top of Spirit Point, a silent monument to its lost twin Opportunity looked over the vast expanse of Endeavor Crater, providing a perspective about just how truly immense this crater was. Imagine standing at the edge of a seemingly infinite bowl, stretching out for miles, its distant walls fading into the hazy Martian horizon. From this vantage point, the sheer scale was humbling, a testament to the colossal forces that had once scarred this ancient world. It was a moment of quiet contemplation for the distant human minds, a profound realization of the vastness they were exploring. From the very onset of its time at Endeavor, Opportunity began discovering phenomena never before seen on Mars. The familiar landscape of its previous explorations, particularly around its initial landing site, had conditioned scientists to expect certain characteristics. You may remember from the previous episodes that the soil found around the areas Opportunity had thus far explored contained countless smooth, tiny round rocks, nicknamed blueberries. These iron-rich spherules were a distinctive feature of Meridiani Planum, a signature of its ancient aqueous past. However, around Endeavor, a subtle yet profound difference became immediately apparent. No blueberries were to be found. Instead, the soil looked much coarser, its grains larger and more angular. The rocks were sharper, and not as rounded, lacking the gentle water-worn edges observed elsewhere. This stark contrast was a powerful indicator of a different geological history, a unique set of forces that had shaped this particular region of Mars. Mission controllers were so impressed by the variation of this area compared to the initial landing site that they said that this section of the mission provided the equivalent of a second landing site for the price of one. It was like discovering a whole new world within the familiar planet, a testament to the rich, diverse geological tapestry of Mars. The first point of interest opportunity meticulously examined at Endeavour was a large ejecta rock called Tisdale II. Imagine a massive boulder hurled across vast distances by the sheer force of a cosmic impact, now resting as a solitary sentinel on the crater rim. This particular rock was unlike any other rock so far examined on Mars. It had distinct volcanic characteristics, hinting at an igneous origin, but with a unique chemical signature, it contained more zinc and bromine than previously seen. These elevated levels were a tantalizing clue, whispering tales of ancient subterranean processes. It was determined to be a type of breccia, a fascinating geological composite formed from old rock fragments having been infused together. This complex composition, particularly the presence of zinc, provided further evidence for water, but in a new, more profound context. Scientists theorized that the impact that threw this bit of ejecta likely released hot underground water that deposited zinc in the rock. Imagine a colossal impact acting as a key unlocking subterranean reservoirs, allowing heated water to circulate through the fractured rock, depositing new minerals in its wake. If this was indeed the case, it showed that water once flowed through underground fractures on Mars, not just on the surface, but deep within its crust. Later analysis of the data opportunity collected showed that not only was this likely to be gypsum, but also that the water here would have been much less acidic than it would have been around other locations on the planet, meaning it could have been more conducive to life. It was a profound revelation, painting a picture of diverse ancient water environments, some perhaps more hospitable than others, just a short distance from Tisdale II. Opportunity made perhaps the most conclusive discovery of its entire mission, a truly groundbreaking revelation that profoundly reshaped our understanding of Mars. Can you guess what it is from this picture? Look closely at the bottom of this image, and you'll see a thin white line exposed in this outcrop. Imagine a delicate, almost ethereal vein running through the ancient rock, a striking contrast to the reddish hues of the Martian surface. This wasn't just any mineral deposit. It was a clear, unambiguous signature. A close-up examination of the vein revealed it to be gypsum, a mineral strongly associated with aqueous environments. The alpha particle X-ray spectrometer on the rover's arm, a sophisticated chemical analysis tool, meticulously detected the minerals calcium and sulfur, together making calcium sulfate. This confirmed the presence of gypsum, a mineral that on Earth often forms in evaporating bodies of water. They named this remarkable vein the Homestake deposit, a name that evokes the idea of striking it rich, of finding a profound treasure. And indeed, it was a treasure. It likely formed from water-dissolving calcium out of volcanic rocks, which combined with sulfur and was then deposited as calcium sulfate into an underground fracture that later became exposed at the surface. Imagine water deep within the Martian crust, slowly dissolving minerals, then migrating through subterranean cracks, leaving behind these mineral veins as silent, enduring signatures. The impact that threw Tisdale II likely had something to do with this vein as well, perhaps fracturing the rock and creating conduits for this mineral-rich water. If this is the case, it shows that water once flowed through underground fractures on Mars, painting a more complex, three-dimensional picture of its ancient hydrological activity. Later analysis of the data opportunity collected from the Homestake deposit deepened the significance of this discovery even further. It showed that not only was this likely to be gypsum, but also that the water here would have been much less acidic than it would have been around other locations on the planet. Imagine a gentler, more neutral water, unlike the highly acidic, sulfuric conditions found in other parts of Mars. This was a critical distinction, for less acidic water would have been more conducive to life. It was a whisper of a more hospitable past, a tantalizing hint that if life ever took root on Mars, these conditions might have offered a more welcoming cradle. As the Martian calendar turned, bringing with it the subtle shift of seasons, Martian winter was setting in. This brought with it a predictable yet challenging set of conditions for our solar-powered rover. There would be shorter days and a lower sun in the sky. For a machine that relies entirely on sunlight to power its systems, and that can't adjust the angle of its solar panels to compensate for the lower sun, this was not the ideal situation. Energy production would inevitably dwindle, posing a threat to its continued operations. But for the first time since the mission began, Opportunity had a unique advantage, a subtle gift from the landscape. It had the opportunity to spend the winter on a slope aimed towards the sun. Imagine finding a perfect, sun-drenched hillside, allowing its solar panels to bask in the limited light, maximizing energy capture even in the darkest days. This meant that for this winter, it would be confined to an area named Grey Haven, a designated winter retreat. This area was not only aimed towards the sun for optimal energy collection, but it was also rocky, meaning Opportunity had a lot it could examine during these few months, transforming a period of potential dormancy into one of focused scientific inquiry. This 360-degree panorama captures the quiet determination of Opportunity's journey to its winter lodgings. You can almost see the tracks of Opportunity as it carefully navigated its way across the rugged terrain, each deliberate turn of its wheels bringing it closer to its sheltered retreat. The very fact that Opportunity had to wait a few months in one spot was actually quite handy, turning a necessity into an opportunity for unique scientific endeavors. One such opportunity arose for its Mossbauer spectrometer, a sophisticated instrument in the rover's arm that uses radiation from cobalt-57 to determine the composition of a sample. This isotope, however, has a half-life of only 9 months, meaning its radioactive potency diminishes over time. This wouldn't have been a problem for a 3-month mission, but Opportunity was now 8 years in, and examining the composition of a rock now took weeks, compared to the half-hour it would have taken at the beginning of the mission. The longer duration of winter allowed for these extended patient analyses, extracting every possible truth from the rocks, despite the instrument's fading strength. When it was not meticulously examining rocks, Opportunity could also use this period of forced stillness to undertake another profound scientific endeavor, to study tiny wobbles in the rotation of Mars to gain insight about the planet's core. Imagine Mars spinning on its axis, but with subtle, almost imperceptible shifts in its rotation, like a top nearing the end of its spin. This precise study requires weeks of radio tracking the motion of a point on the surface of Mars to measure changes in the spin axis of the planet. Something which couldn't be done before, as Opportunity was always on the move. The wobbles they were looking for would indicate whether the interior of Mars is still molten or not. It was a way to probe the very heart of the planet, revealing whether its ancient core still flowed like a liquid or had solidified over eons. Opportunity's winter wait also meant it could examine another subtle yet powerful force shaping the Martian landscape, the effects of wind on the dunes of Mars from a ground perspective. Even at the microscopic level, using the microscopic camera on the rover's arm, it could patiently observe and study, checking for slight changes over the months it was stationary. Imagine witnessing the imperceptible dance of sand grains sculpted by the gentle breath of Mars over vast stretches of time. This provided invaluable data on aeolian processes, the way wind ceaselessly shapes the Martian surface, even when the rover itself was at rest. Each grain, each ripple, a silent testament to the planet's dynamic, enduring beauty. Months had passed, and the quiet stillness of Martian winter was slowly giving way to the promise of spring. On Sol 2947, Opportunity, our resilient explorer moved again for the first time since it set up camp in Grey Haven. Imagine the quiet relief, the silent celebration back on Earth as the telemetry confirmed movement. Luckily, everything that was functioning from before seemed to still be functioning, a testament to the careful wintering strategy and the rover's enduring robustness. And with its systems re-engaged, Opportunity headed out to the next point of interest. Data suggested clays were present in this area, a tantalizing whisper of ancient water. The mission team, ever persistent, were determined to find it. A beckoning outcrop was spotted around Sol 3057, a promising rise in the terrain that seemed to hold the secrets they sought. And when the microscopic camera revealed something about it that no one was expecting, a profound and unexpected twist in the narrative of Mars's geological history. Much like Opportunity's initial landing site, these smooth, polished blueberry rocks were observed. Imagine the surprise, the sudden re-encounter with a familiar, yet now subtly different geological signature. However, this time, they were very much a part of the rock, not loose spherules on the surface, but integrated into the very fabric of the stone. They were also smaller than what Opportunity had seen before, only a few millimeters in diameter, tiny versions of their larger counterparts. And crucially, they were not rich in iron, like the landing site blueberries, suggesting a different formation process or chemical environment. A few of the exposed blueberries observed had been eroded away, revealing their internal structure. Scientists analyzing these minute details described these particular blueberries as crunchy on the outside and softer in the middle. They were different in concentration. They were different in structure. They were different in composition. They were different in distribution. It was quite the mystery, a profound puzzle that challenged previous assumptions and invited deeper inquiry into the diverse geological processes that had shaped Mars over eons. Opportunity had just one more place to visit on its long and arduous trip around Cape York, a final destination before moving on to new horizons. And that was the clay patch dubbed Whitewater Lake. Imagine a subtle depression in the landscape, hinting at a past where liquid water had pooled, leaving behind these unique mineral signatures. On its way there, the Earth and Mars were just going through a phase called solar conjunction, where Mars is behind the Sun, which blocks communications between mission controllers in the rover. This is a predictable celestial alignment, a period of forced silence in the cosmic conversation. This has happened a few times during the course of the mission already, but this time, Opportunity gave mission controllers a bit of a scare. As during the communications blackout, Opportunity's onboard computer reset into standby mode. Imagine the sudden silence, the unexpected shift in status, a moment of profound anxiety for the team. Thankfully, communications were restored. Opportunity booted back up properly, and it carried on to Whitewater Lake. It was a momentary tremor, a reminder of the fragility of remote operations, and it was there at Whitewater Lake that Opportunity made another truly groundbreaking discovery, a profound confirmation of Mars's ancient hydrological past. Opportunity discovered Esperance, the pale rock in the upper center of this image, which is about the size of a human forearm. This was it the treasure scientists had been looking for, a tangible piece of evidence for long-term water interaction. Esperance's composition was found to be higher in aluminum and silica and lower in calcium and iron, a distinct chemical signature. More so than any other rock Opportunity had examined in more than 9 years, on Mars, making it truly unique. Crucially, testing found that this rock had a clay mineral content due to intense alteration by water. Imagine water permeating the rock for vast spans of time, slowly transforming its mineral composition, leaving behind these distinct clay signatures. Opportunity spent weeks here, making sure the measurements were correct, getting everything it could get done before Martian winter came around again. It was a meticulous, patient effort to extract every possible piece of truth from this remarkable discovery. With the profound insights gained from Esperance, sights were now set on a place called Candor Point, a sun-facing slope on the next hill, 1.5 kilometers further south. This new destination promised more evidence of hydrated minerals, beckoning opportunity onward. Our tireless rover left Cape York on Sol 3344, having spent 9 Earth years, or 5 Martian years on Mars's surface. It had found the best evidence out of any Mars mission that neutral pH water once existed on Mars, a groundbreaking revelation that transformed our understanding of Mars's ancient habitability. Even though this huge discovery had been made, Opportunity still had a lot ahead of it. Mission controllers wanted more evidence of water driven by an insatiable scientific curiosity, and they had their sights set on Candor Point, a new horizon, promising even deeper secrets. The journey towards Candor Point, a sun-facing slope on the next hill, about 1.5 kilometers further south from Esperance, was Opportunity's next profound objective. Mission controllers, their scientific curiosity unyielding, wanted more evidence of water and even deeper understanding of Mars's ancient hydrological past. Candor Point, with its promise of additional hydrated minerals and exposed layering in the rocks as spotted by the Mars Reconnaissance Orbiter, beckoned our tireless rover onward. That 1.5 kilometers doesn't seem so far away to our human perception, a mere stroll in an afternoon. But Opportunity was a slow rover with a top speed of only 2 centimeters a second, a deliberate crawl across the vastness of an alien world. And it often traveled half that, just to be safe, its movements, meticulous, cautious, driven by the paramount need to protect its precious instruments. Scientists didn't want it to crash into rocks or get stuck in sand dunes, either of which could spell a sudden silent end to its remarkable journey. So Opportunity would move forward a bit, look around for hazards, and repeat the process, an intricate, patient dance of remote exploration. Along the way, the floor underneath Opportunity looked very peculiar. It was not the uniform flat plains it had often traversed. Instead, it was primarily large chunks of rocks smoothed off at the top, with sand and dust filling the gaps almost like a random mosaic. Imagine an ancient shattered pavement, its broken pieces gradually smoothed by the ceaseless work of wind and time, with fine Martian dust settling into the crevices. This unique terrain, surprisingly, was ideal. Flat rocky ground is the ideal terrain for Opportunity, offering stable footing and minimizing the risk of wheel slippage. And so, despite its unusual appearance, it made good progress on the way to Candor Point, each turn of its wheels a steady, reliable advance. As it continued its methodical journey, a familiar sight greeted Opportunity. Blueberries was spotted again. These were the rounded rocks, typically a centimeter or 2 across, that had become a signature of its initial landing site, hinting at ancient water activity. Their reappearance even in this new locale served as a subtle reminder of the widespread nature of water's past influence on the Martian landscape, a consistent whisper of its ancient presence. By Sol 3390, Opportunity made it to its winter lodgings at Candor Point and began work on the slope. This was a strategic decision, positioning itself to maximize the precious dwindling sunlight of the Martian winter. Even while working here, energy production was very low-hitting, only 270 watt-hours per day. This was a precarious level. Any lower than that, and the rover would have gone into a type of hibernation mode, a deep power-saving sleep, to protect its vital systems from the extreme cold. This low energy output was not only due to the Martian winter and the lower sun angle, but also because dust had been settling on the rover solar panels, and there hadn't been a cleaning event for a while, the insidious accumulation slowly choking its light. This low power mode meant the work around Candor Point was slow and painstaking. Opportunity had to conserve every precious watt and carefully prioritizing its tasks. It wasn't until Sol 3530 that the cleaning event finally pushed energy production up to 370 watt-hours per day, a welcome resurgence of power that invigorated its operations. These cleaning events occur when wind blows extremely fine dust off the panels. Because Mars is so arid, there's nothing adhesive about the dust, so even though Mars's atmosphere is so thin, these dust particles can be easily blown off a bit, like blowing dust off the cover of a book. This reliance on the whims of the Martian wind was a constant reminder of Opportunity's fragile existence. Dust settles on the rover over time, especially during the massive dust storms that are so big they can be seen from space, these colossal atmospheric events depositing a fine pervasive layer across everything. Around Sol 3519, Opportunity spent the day examining a surface target, a specific rock it had identified for detailed analysis. However, rather embarrassingly from the perspective of the engineers back on Earth, the mesh they used to calculate the distances of objects to the rover was wrong, a subtle yet critical calibration error. This meant the instruments on the arm were off by about 5 centimeters, a small but significant misalignment. As a result, the images taken were blurry, lacking the crisp detail vital for scientific inquiry, and the alpha particle X-ray spectrometer couldn't properly detect what it was looking at. It was a frustrating setback, a moment of unexpected imperfection. Thankfully, this was quickly rectified, and the usual crisp images started coming back to mission control again, allowing Opportunity to resume its meticulous scientific work with its precise vision restored. A bizarre discovery that was noticed just a few sols later added a touch of mystery to Opportunity's journey. This was something known as Pinnacle Island. Opportunity often took days to examine certain patches of ground, meticulously capturing details. But scientists noticed some variation between one photo and another taken a few days later. In the space of those few sols, a new rock seemed to have appeared out of nowhere. Imagine the quiet surprise, the raised eyebrows among the mission team back on Earth. Mission controllers weren't so impressed, though, with the sudden appearance of Pinnacle Island, initially putting it down to a more mundane explanation. They theorized it was either a nearby meteorite impact that had dislodged the rock, or even Opportunity itself bumping the rock into place with one of its wheels during a maneuver. A flyby of the Mars Reconnaissance Orbiter revealed no fresh impact, effectively discounting that theory. But mission controllers eager to press on with the broader scientific objectives sent Opportunity on its merry way without investigating the rock further. This caused outrage online, a surge of speculation, and imaginative theories. People suspected aliens left the rock there as a means of communicating with us on Earth, or that it was a type of fungus that had grown over the 12 days between photos thriving in the alien environment. Some people even went to the lengths of suing NASA over their reluctance to investigate Pinnacle Island further. By imagining it with the microscopic camera on board Opportunity's arm, the mystery captivated the public imagination, transforming a simple rock into a potential cosmic enigma. However, before that speculation really got going, as Opportunity, following its programmed path, looked back on Pinnacle Island, the mystery was solved, not by aliens or fungi, but by the quiet, diligent observations of the rover itself. The truth in its elegant simplicity was revealed. Opportunity had indeed cracked a rock in half. You can clearly see this by the tracks left in the sand, a subtle but undeniable confirmation of its accidental involvement. As far as we are aware, this was the first time something like this has happened on its whole mission, a unique, inadvertent geological alteration. But the chances of it occurring were likely increased, as Opportunity's arm was getting less and less mobile through wear and tear, forcing the rover to make more complex turns with its body to position the arm. This meant that the rover itself now has to turn in order for the arm to reach specific objects, instead of the arm simply reaching across, increasing the likelihood of accidental contact with the surrounding terrain. Another problem that was becoming more and more persistent for Opportunity was the onboard computer randomly resetting. Imagine the frustration the rover diligently collecting data suddenly experiences a brief, inexplicable blackout, forcing a restart. Although Opportunity was always able to turn back on each reset, wasted about a day's worth of science activities, precious time lost in the relentless quest for knowledge. By Sol 3749, these resets caused about half the month to be missed, a significant disruption to its operations. Controllers narrowed the problem down to the onboard flash memory. Flash memory, much like memory cards in our cameras, can get temperamental after repeated use, its cells degrading over time. This heightened the risk of losing new photos before they can be sent back to Earth, a terrifying prospect for a mission where every piece of data is invaluable. And so a decisive action was taken. The decision was made to reformat the entire drive. This was a drastic step, but a necessary one. It would not only clear the storage, but also identify any bad cells within the drive, so those cells can be avoided in the future, isolating the faulty sections to prevent further issues. By Sol 3773, the reformatting was completed successfully, a significant victory in the ongoing battle against mechanical degradation. Soon thereafter, Opportunity reached Back Ridge south of Candor Point, continuing its methodical exploration of the Endeavour region. As this was going on, a remarkable celestial event unfolded, a visitor from the far reaches of our solar system hurtling towards Mars. Its trajectory would take it just 130,000 kilometers above the planet's surface before it continued on towards the Sun. This visitor was again not an alien, but Comet Siding Spring, a transient guest from the Oort cloud. The Oort cloud is found well beyond Neptune and the Kuiper belt, a vast spherical shell of icy objects, millions of icy rocks in orbits that take millions of years to complete, because it had such a long time to accelerate towards the Sun. From the furthest point in its orbit, the trip from Mars to the closest approached the Sun only took 6 days, hurtling through space at an astonishing 56 kilometers per second. However, because of the close flyby of Mars, it meant that the spacecraft on and around Mars were actually in a better spot to witness Comet Siding Spring than we were on Earth. Imagine having a front row seat to a cosmic spectacle. Mission controllers of the various missions were also a bit nervous about the dust particles that are ejected from the comet traveling at that speed, potentially impacting and damaging spacecraft in orbit around Mars. As such, Hubble as well as spacecraft around Mars all began observations of this visitor, turning every available eye towards the incoming cosmic guest. Fortunately, mission controllers had already had some practice at this with Comet Ison, another comet that passed by Mars only the year previously. Comet Ison, however, was 80 times further away than Siding Spring would be too far and too dim for Opportunity to spot. And unfortunately, it was day just deciding Spring made its closest approach to Mars, meaning Opportunity couldn't observe it in the dark Martian sky. But Opportunity was able to snap a couple of photos of it just before dawn. Imagine the faint light of a new Martian day with the ghostly outline of a distant comet hanging in the pre-dawn sky. Can you spot it? Here's the annotated version of the same image, revealing the faint ethereal presence of the celestial visitor. As Comet Siding Spring passed by, a profound silence from the cosmos. None of the spacecraft were damaged by ejected dust particles, a collective sigh of relief for the mission teams. But what they did observe from this flyby was completely unexpected. As it passed by, it plunged Mars's weak magnetic field into chaos, albeit temporarily. Unlike Earth, Mars doesn't have a magnetic field generated from within its core by a powerful dynamo. Its magnetic field comes from plasma high up in its atmosphere, which generates a very weak charge. This is enough to deflect solar wind coming from the Sun, but solar storms from CMEs and solar flares push past this induced magnetic field, stripping away atoms from the atmosphere. Comet Siding Spring had a very similar effect on Mars, a surprising demonstration of cosmic interactions. Comets are also surrounded by a magnetic field, again induced from interactions with solar wind, this time with the comet's atmosphere or coma. A comet's coma can reach out for millions of kilometers from the comet, meaning that as Siding Spring passed Mars, Mars was enveloped in its coma for a good few hours. This merged both magnetic fields for the duration of the event, with charged particles from both objects interacting strongly with each other. And remarkably, the atmosphere of Mars actually lost some particles to space. As a result, a subtle yet significant atmospheric stripping event. However, apart from the image Opportunity was able to take from the surface, all this went largely unnoticed by the rover, a testament to its singular focus on the geological stories beneath its wheels. 2015 was quickly approaching, and Opportunity was heading for Marathon Valley, a significant waypoint that would take the odometer reading of Opportunity to the distance of a typical marathon, completing a marathon in 11 years. Think of that. A robotic marathon runner slowly but surely covering the equivalent of 42 kilometers or 26.2 miles across an alien world. That's a pretty impressive finishing time for a machine, a testament to its incredible endurance. In celebration of this milestone mission, controllers took part in a relay marathon with a replica of Opportunity as they crossed the 42 kilometers or the 26.2 mile mark, a poignant symbolic act of solidarity with their distant explorer. But there was more to Marathon Valley than just a waypoint. There were interesting rocks here that mission controllers wanted to investigate. To get down into Marathon Valley, Opportunity had to go down the steepest slope it had faced, yet 32 degrees. Imagine the precarious descent, a careful gripping crawl down an incline that would challenge even a human climber. Such was the steepness of this slope that dust that had built up on the solar panels began to flow off a natural cleaning event triggered by the angle itself after successfully descending down the slope. Opportunity first investigated a region known as the Spirit of St. Louis. It's actually a small crater, yet it has some outcrop exposed offering tantalizing glimpses into the subsurface. Unfortunately, it was around here that the flash memory caused the onboard computer to reset again, a recurring frustrating issue. Although mission controllers had narrowed down the problem to a specific cell bank on the flash drive, quarantining this section apparently hadn't completely solved the problem. The solution had helped somewhat, though. A reset once a month is a lot better than the few times a day they were getting before the reformatting and quarantining. Eventually, though, engineers decided to bypass the flash memory altogether and operate the rover in RAM-only mode. The danger there, though, was that ROM gets wiped if the computer switches off, meaning any scientific data not transmitted back to Earth is at risk of being lost forever should the onboard computer turn off. It was a risky but necessary compromise, prioritizing immediate data acquisition over long-term storage integrity. The northern edge of Marathon Valley was a ridge named Hin Point. To the south was a ridge named Knudsen Ridge. In these regions, Opportunity was again looking for clays, past evidence of liquid water oceans on Mars. Mission controllers detected clays on these ridges from orbit with the MRO, which correspond to these reddish areas seen in the enhanced color versions of these photos. Opportunity found these rocks to be brittle and to disintegrate a lot easier than other rocks it had previously observed, as well as having unusual compositions. They were unlike a lot of other rocks in the area, suggesting a unique geological formation. Although data collection was constant here, it was also extremely slow-going. The alpha spectrometer on Opportunity's arm was losing its potency, meaning sample analysis that would have taken minutes at the beginning of the mission would now take days or weeks. This was also combined with Opportunity's temperamental onboard computer, which was really starting to struggle, adding to the delays. As a result, it took Opportunity well over a year to get through Marathon Valley, a testament to the cumulative challenges and the slowing pace of its incredible longevity. It began to head deeper into Endeavor and was greeted with a spectacular sight. A dust devil was spotted on the crater floor. Spirit Opportunity's sister Rover had seen dust devils in the past, but they were a lot rarer for Opportunity. It is believed that dust devils passing over the rovers had been responsible for the occasional cleaning events that removed dust off the rover solar panels, those benevolent whirlwinds acting as a vital lifeline. Opportunity's next goal was again found further south, a gully that scientists believe might have been carved out by water. A gully had never been closely examined by a Mars mission in the past, so scientists were excited by what they might find, a new type of feature to investigate. But getting there was tricky. On its way down the crater rim, it passed through a gap in this ridge named the Lewis and Clark Gap down Bitterroot Valley to Spirit Mound. On its way down, it took some spectacular panoramas of various ridges overlooking the sand dunes, stretching across the crater floor, capturing the majestic beauty of this ancient landscape. Upon reaching Spirit Mound, Opportunity had been on Mars for well over 4,500 sols, roughly 12 Earth years. All things considered, Opportunity was in reasonable health and generating a very comfortable 450 watts of power from its solar panels. On its way to the gully, it would stop periodically to perform some science operations like imaging select rocks and measuring argon in the atmosphere, diligently collecting every possible piece of data. Opportunity finally reached the gully in September 2017. The gully was named Perseverance Valley, a fitting name foreshadowing the spirit of a future rover. Scientists wanted to know whether it was water ice or wind that had carved this gully from the shape of the gully. It certainly looks to have had something flow down it. Opportunity also spotted rocks aligning the channels. Could these have been deposited by water currents? As it turned out, Opportunity wasn't able to find anything conclusive after several months of examining the area. The mystery of Perseverance Valley remained a question for future explorers. Opportunity passed through 5,000 sols on Mars, a staggering milestone. And what better way to celebrate than by taking its first full selfie? You'll notice this image is blurry. That's because it was taken with the fixed focus microscopic imager on its arm. It was only designed for very close targets, a limitation that ironically created a unique artistic self-portrait. In June of 2018, the MRO detected the formation of a dust storm. This isn't unusual. Mars has seen its fair share of dust storms coming and going on a fairly regular basis. Opportunity had even lived through itself. However, within days of its formation, it was clear that this was going to be a big one. It very quickly spread across the entire planet, engulfing Mars in a vast opaque shroud, and mission controllers began preparations for a period of low power. On the 3rd of June, Opportunity was producing 468 watts of power. By the next day, this had dropped to 345 watts. By the 6th of June, it had plummeted to 133 watts. Dust caught up in this storm filled the atmosphere, obscuring the precious light from the sun to the point where it would have barely even been visible. The worst storm Opportunity had experienced up until this point was in 2007, where the atmospheric opacity, known as a tau value, was at 5.5. This was almost enough for Opportunity to not make it through. This storm, on the other hand, had a tau value of 10.8, almost twice as bad as the previous storm, a truly unprecedented event. Although operations were kept very basic, only sending back health reports every morning and evening by the 12th of June, Opportunity fell into a continuous hibernation mode. The storm dragged on for months, and with each passing day, mission controllers lost more hope that Opportunity would wake up on the other side. 3 months later, the storm finally subsided enough for Opportunity to wake up from its hibernation mode, and efforts were made to re-establish contact with Opportunity. By October, the storm had cleared completely, the Martian sky returning to its normal hues. But no contact had been made with the rover. Even after 350 attempts from November, on mission controllers hoped that if the rover simply had a lot of dust on his panels, that wind would blow a lot of it off. However, 1,000 communication attempts later, all the way through to February, mission controllers gave up hope and declared the mission dead. MER project, off the net. The 15-year or 5 to 352 Sol-Mars mission had finally ended, and what a mission it was. Opportunity measured temperatures, atmospheric readings, the rotation of Mars, and more. However, the real prize was the definitive proof that Mars was once a world similar to our own, in that it held stable bodies of liquid water oceans on its surface in the distant past. While we may take that for granted now, when it was first confirmed, it was truly groundbreaking. Shortly before communication was cut off, Opportunity was in the process of sending back one last panorama of its final resting place. Its famous last communication was poetically translated to be, "My battery is low, and it's getting dark," and its final image was of the sun obscured by the dust, a poignant farewell. And there we have it, a recap of the entire Opportunity mission,